Look up on a clear night and the Milky Way gives the impression of permanence. A pale river, a quiet band of light, something so old, so large, and so indifferent to us that it seems to have moved beyond change. That impression is false. The Milky Way is not sitting there in finished form, waiting to be admired. It is gaining matter right now. Small galaxies are being stretched into stellar ribbons by its gravity. Gas is falling toward its disk from the halo above it. Molecular clouds are collapsing into new stars. The shape we call our galaxy is not a completed structure. It is an ongoing event. And that changes the meaning of the sky. Because once you see the Milky Way clearly, it stops looking like a backdrop and starts looking like a system under continuous construction and continuous consumption. That is the first rupture. We are almost trained to think of galaxies as landmarks, enormous, luminous landmarks. Yes, but settled ones. As if a galaxy is like a continent in space, formed long ago, still standing now, changing only in some technical sense too slow to matter. But a real galaxy is closer to weather than architecture. Not because it is chaotic in the ordinary sense. The Milky Way is lawful. Its stars move according to gravity with extraordinary precision. Gas cools, falls, compresses, and ignites under rules we can model. Satellite galaxies rise and fall through orbital mechanics that can be measured, tracked, and reconstructed across immense spans of time. And yet all of that order is not the stillness of a finished object. It is the order of a process still unfolding. Even the phrase "our galaxy" softens the truth. It makes the Milky Way sound like territory, something fixed enough to belong to us. But the Milky Way was assembling itself long before the sun existed, and it will go on reorganizing itself long after every trace of Earth is gone. We do not live inside a completed home. We live inside a gravitational system that is not finished becoming what it is. That sounds poetic until you make it specific. Right now, the Sagittarius dwarf galaxy is being torn apart by the Milky Way's tidal field. Not all at once, not in a burst of fire, more slowly than that, more patiently, in some ways, more cruelly. The side of Sagittarius closer to the Milky Way feels a stronger pull than the far side. That difference in gravity stretches the dwarf galaxy, strips stars from its edges, and pulls them into long streams that wrap around our own galaxy like luminous wreckage. This is not some ancient cosmic crime we only guessed at after the fact. We have mapped those streams. We can trace the debris. We can watch the evidence of a galaxy losing its separate identity piece by piece. Our galaxy is eating another galaxy. Not metaphorically, not as a dramatic flourish, gravitationally, mechanically, observably. And Sagittarius is only the case that makes the principle impossible to ignore. Because the Milky Way does not grow in just one way. Some of its growth is violent enough to leave visible scars. Some of it is so slow that the eye mistakes it for peace. Gas cools and settles into the galactic disk. Dense regions collapse under their own weight. New stars ignite. To human intuition, that looks like simple creation. A star is born. Light appears. The galaxy becomes richer. But that light arrives late. Long before a star turns on, matter has already been moving through darkness, drifting, cooling, gathering, sinking into a deeper gravitational order. By the time fusion begins, the real story has already been underway for millions of years. A star is not the beginning of the story. A star is what the story looks like once it becomes visible. And that is why the night sky is so deceptive. It gives us the bright layer and hides the machinery. We see stars, we see dust lanes, we see the luminous strip of the galactic plane. We do not naturally see infall. We do not naturally see tidal stripping. We do not naturally see the slow transfer of gas from halo to disk. We do not naturally see that what appears serene at human speed is violent at galactic scale. The eye is innocent, physics is not. Human perception was never built for billion-year processes. We interpret slow inevitability as stillness. We mistake continuity for permanence. We see a structure that persists across our lives and assume it is complete. But the Milky Way is not complete. It is gaining stars. It is gaining gas. It is redistributing old matter into new forms. It is changing orbit by orbit, cloud by cloud, passage by passage. Even the phrase every single day is almost too crude for it. The galaxy does not wait for days. Its transformation is continuous. Somewhere in the disk, gas is reaching the density where gravity will overpower pressure. Somewhere in the halo, stars stripped from an absorbed dwarf are drifting farther from the remnant that once held them. Somewhere above the galactic plane, material is moving through the hot corona that surrounds the Milky Way, on its way toward becoming part of a future generation of stars. This is happening now. Not in the dramatic way the human nervous system prefers, not with a single explosion we can point to and call the event, but with the harder kind of reality, the kind that goes on whether we notice it or not. The Milky Way forms new stars at roughly 1 to a few solar masses per year, spread across the full scale of the galaxy. That can sound almost disappointingly modest until you translate it into something the body can feel. In about a week, the Milky Way turns roughly an Earth's worth of matter into stars. An entire planet's mass every week. Not in one furnace, not in one nebula, across an enormous rotating disk, through many clouds, under many local conditions, continuously. Its growth is distributed, patient, and relentless. And it is not only making new structure, it is inheriting old structure from elsewhere. The stellar halo around the Milky Way is not just a sparse cloud of ancient stars. Much of it is debris, fossil evidence of earlier mergers, shredded remains of smaller galaxies taken apart and mixed into our own. What looks like a faint outskirts is, in part, a graveyard. The halo is not background. It is memory. This is where the familiar picture of the Milky Way begins to fail completely. Because once you understand that galaxies grow by capture, stripping, inflow, collapse, and recycling, the galaxy in the sky stops looking like an object and starts looking like a history still happening. A history written in different speeds. Some of it unfolds so slowly that only careful measurement can reveal it. Some of it becomes visible in the birth of stars. Some of it survives as streams, long, cold ribbons of stars that used to belong to something else. Some of it is hidden altogether, implied only by motions that should not be possible if the visible galaxy were all there was. And that last detail matters more than it seems. Because if the Milky Way is still growing, the next question is unavoidable. What exactly is doing the holding? What kind of structure can keep such a vast system together while it feeds, rotates, absorbs, and survives for billions of years? The answer is where the galaxy becomes stranger than its light. Because the Milky Way is not held together by what we can see. That is one of the deepest and most unsettling facts in modern astronomy. Not because it is mystical, not because it invites fantasy, but because it means the bright galaxy human beings have stared at for thousands of years is only the exposed surface of a much larger thing. The stars are not the whole structure. They are the part that happens to shine. If you could step far enough outside the Milky Way and look at it with human eyes alone, you would see something magnificent but incomplete, a barred spiral of starlight, dust, and gas, turning in darkness. What you would not see is most of the mass actually shaping that motion. You would not see the vast surrounding halo whose gravity governs the outer galaxy. You would not see the hidden scaffold that made the visible Milky Way possible long before the disk settled into its present form. And yet the stars tell on it. They tell on it through their speed. When astronomers began measuring how fast stars and gas move through galaxies, they expected to find something intuitive. The farther you go from the dense, bright center, the weaker gravity from the visible matter should become, motion should taper off. Outer stars should orbit more slowly. The way planets farther from the sun move more gradually than the inner ones. That expectation was not irrational. It was the clean extrapolation of ordinary gravitational logic applied to luminous matter. But the Milky Way, like other large galaxies, did not cooperate with that intuition. Far from the center, stars kept moving too fast. Not absurdly fast in some theatrical sense, more disturbing than that. They move fast enough, persistently enough, and over a large enough range that the numbers stopped making sense if you counted only what was glowing. The visible galaxy did not contain enough mass to explain the motion of its outskirts. by the arithmetic of gravity, the outer Milky Way should have been looser than it was, more fragile than it was, less coherent than it was. And yet it held. The galaxy was behaving as though it were embedded inside something larger, heavier, and mostly unseen. This was not a decorative mystery. It was structural. A galaxy is not simply a bag of stars drifting together because they formed in the same neighborhood. It is a gravitational arrangement, its long-term shape, its survival, its ability to keep stars bound over billions of years. All of that depends on mass. If the mass you can see is not enough, then the real galaxy extends beyond the part that your eyes would call the galaxy at all. Which means the luminous Milky Way is, in a very literal sense, misleading. Not false, just incomplete in the most important way. The visible disk is the bright skin of a deeper object. That is why the old image of the galaxy as a serene wheel of stars becomes harder to sustain the closer we look. Because once motion enters the picture, appearance loses authority. Light tells you what is there to be seen. Motion tells you what is there to do, the holding. And when those two accounts diverge, physics takes the side of motion. This is where the Milky Way begins to feel less like scenery and more like a buried machine. Imagine walking into a vast dark room and hearing heavy machinery turning somewhere beyond the walls. You cannot see the motors. You cannot see the belts or the flywheels or the frame that keeps the whole system under tension. But the rhythm of motion reaches you anyway. Every vibration tells you there is more structure present than your eyes can account for. That is what galactic dynamics did to the Milky Way. They revealed that the visible galaxy was nested inside a much larger gravitational order. What we call dark matter is the name we give to that hidden mass component, not because it is a magical substance invented to protect a theory, but because something unseen is required to explain the behavior of galaxies on large scales. In the Milky Way, the evidence appears in the flatness of the rotation curve, in the motion of stars far from the center, in the way satellite galaxies orbit, in the way the galaxy has remained bound and assembled over cosmic time. You do not need to solve the underlying particle physics to understand the immediate implication. The Milky Way was never held together by its light. That sentence matters because it changes the story of growth. If the visible galaxy were all there was, then the Milky Way would be a more delicate thing, easier to strip, harder to build, less capable of capturing and retaining material across enormous distances. But wrapped around the bright disk is a much more extended halo of mass, a deep gravitational basin into which gas can fall, satellites can descend, and tidal debris can remain trapped long enough to be folded into the larger whole. The Milky Way does not merely contain stars. It sits inside an invisible well that decides which matter can become part of it. And that well is enormous. The stellar disk of the Milky Way is vast by human standards, but the dark halo surrounding it stretches much farther, extending deep into the region where the galaxy's authority over smaller neighbors is established. This is why the phrase, "our galaxy," becomes stranger the longer you hold it in your mind. Where does the galaxy really end? At the visible edge of the disk, at the last faint stars of the halo, at the range over which its gravity can dominate orbiting satellites, at the diffuse outer territory where matter is only partly captured and not yet settled? The answer is uncomfortable in a useful way. A galaxy is not a line. It is a hierarchy of influence. Its visible form is only the most photogenic part of a much larger domain of control. That realization also helps explain something easy to miss in the opening rupture. If the Milky Way is swallowing smaller galaxies, it is not doing so as a simple luminous disk reaching out and grabbing them. It is doing so as an extended gravitational structure whose visible stars are only the central, radiant expression of a deeper mass distribution. Long before a dwarf galaxy is shredded into streams, it is already moving inside that larger invisible territory. In other words, the act of devouring begins before the violence becomes visible. By the time we see a galaxy like Sagittarius being stretched apart, the real capture happened earlier. The orbital trap had already been sprung. The dwarf had already fallen into a gravitational regime from which separate survival would become harder with every pass. That is how galaxies eat with patience. Not like predators in the biological sense, with sudden lunges and obvious impacts. More like deep wells in space-time that keep whatever wanders too close. then gradually strip, heat, mix, and absorb it over repeated encounters. The drama unfolds slowly enough that the universe never needs spectacle to prove its severity. Gravity has no need to hurry. And there is another consequence, even more important than the existence of the halo itself. The hidden mass around the Milky Way did not merely help maintain the modern galaxy after it formed. It helped make formation possible in the first place. Because ordinary matter, the atoms that become stars, gas clouds, dust, planets, oceans, and bodies, does not simply organize itself into a giant spiral because it feels like doing so. It needs a landscape of gravity. It needs regions where matter can accumulate rather than disperse. It needs a place where gas can fall, collide, cool, lose energy, and settle. The luminous Milky Way came later. First, there had to be the basin. First, there had to be the deeper structure into which normal matter could descend. This is where the emotional character of the galaxy changes again. The Milky Way is not just a star city supported by hidden mass somewhere in the background. It is a visible condensation inside a much older gravitational arrangement. The stars, the spiral arms, the sun, the clouds that formed Earth. All of it belongs to a history that began before anything in the galaxy was bright enough to look like home. Home entered late. That is not how the night sky feels. The sky feels immediate. It feels self-presenting. It feels as though the light is the thing. But the deeper truth is harsher and more elegant. The visible galaxy is what happened after matter fell into a structure we still cannot see directly. The stars came later. Gravity prepared the room first. Once that becomes clear, another illusion breaks with it. We often imagine cosmic history as a story in which visible things appear and then interact. First stars, then galaxies, then mergers, then planets, as though the universe builds itself in the same order that the eye learns to recognize it. But the universe does not respect the order of human recognition. The hidden framework comes first. The visible drama follows. And that means the Milky Way did not begin as a shining spiral waiting to live out its fate. It began as a concentration of invisible gravitational potential, a place where matter would eventually gather, where collisions would dissipate energy, where gas would settle, where stars would turn on, and where later generations of smaller systems would be captured, stripped, and absorbed. The galaxy we admire is the late visible phase of a deeper architecture, which also means that when we say the Milky Way grows, we are already speaking too narrowly if we only mean stars being added to a disk. The real growth begins earlier and extends farther. Matter enters the halo before it joins the galaxy in any familiar visual sense. Satellite systems become dynamically bound before they are visibly torn apart. Gas falls into the wider structure before it ever takes part in star formation. Growth starts in the dark. By the time it shines, it has already been happening for a very long time. And this is the pressure point that leads forward, because once you stop treating the Milky Way as a luminous object and start treating it as a deep gravitational structure, its history changes shape. The galaxy no longer looks like something that simply formed and then decorated itself with stars. It begins to look like a place where capture was always going to matter, where infall was always going to matter, where the visible order we call a galaxy emerged from earlier hidden assembly. Which means the next question is no longer just what the Milky Way is. The real question is how something like this begins, and why a galaxy grows by eating before it ever looks calm enough to be called home. To answer that, we have to move backward past the stars, past the spiral arms, past the glowing gas, past the familiar image of a galaxy as a wheel of light suspended in blackness. Because the Milky Way did not begin as a shining structure, it began as a gravitational opportunity. That phrase sounds abstract, but the reality behind it is severe. In the early universe, matter was not arranged into finished islands waiting to be discovered. It was distributed more simply than that. Hot, dense at first, then expanding, cooling, and gradually allowing small differences in density to matter. Tiny irregularities in the distribution of matter, almost unimaginably slight at the start, became the seeds of everything that followed. In some regions, there was just a little more gravitational pull than in others. Not enough to look dramatic, more dangerous than dramatic, enough to begin changing the future. That is how cosmic structure starts. not with beauty, with imbalance. Over time, those denser regions pulled in more material. As they grew heavier, their pull deepened. As their pull deepened, they gathered more matter still. This is one of the universe's most relentless habits. Once gravity gains an advantage, it tends to widen it. A small excess becomes a deeper well. A deeper well becomes a place where matter can accumulate. Accumulated matter becomes the beginning of a larger structure. The process is not fast by human standards, but it is mercilessly cumulative. And crucially, the first large structures were not built out of starlight. They were built out of mass. This is why galaxies become misleading if you imagine their history in visual terms. The eye wants to begin where the light begins, but the true beginning lies earlier, in regions of invisible structure that ordinary matter had not yet fully entered. Before there was a Milky Way in any recognizable sense, there were smaller gravitational concentrations, halos and subhalos, places where matter could begin to gather and where later assembly would become possible. The universe did not build one grand spiral from scratch. It built many smaller structures first. This is one of the most important shifts in the entire story, because it destroys the gentle fantasy that galaxies arrive as singular masterpieces. They do not, they are assembled. They inherit material from what came before. They rise out of repeated mergers, repeated captures, repeated episodes of infall. The calm spiral seen from a distance is the late visible expression of a long chain of earlier violence. A galaxy grows by accumulation before it grows by elegance. And in the beginning, that accumulation was brutal. The young universe contained many small proto-galactic systems, not miniature modern spirals with neat arms and luminous symmetry, but rougher, denser, less settled structures. Some held gas, some had already formed early stars. Some were mostly dark matter with only limited luminous material. They orbited, approached, interacted, merged. Larger systems formed by absorbing smaller ones. Smaller systems were stretched, heated, deformed, or erased. Gas was shocked, compressed, and redirected. Angular momentum was redistributed. Some material settled into rotating structures. Some was flung outward. Some remained in the hotter, more chaotic states. Nothing about this resembles a clean birth. It is closer to geological pressure than to invention. A galaxy is not made the way a building is made. It is made the way a coastline is made, through countless forces acting across absurd spans of time until a stable shape emerges from what was once only turbulence and collision. But even that comparison is too gentle, because coastlines are shaped by erosion, galaxies are shaped by capture. The Milky Way was not exempt from this. Long before our sun formed, long before Earth condensed from the remnants of dead stars, the growing structure that would become the Milky Way was already swallowing smaller systems and incorporating their matter. Some of those early mergers were major enough to change the galaxy's overall structure. Some heated its young stellar populations and helped build what we now call the thick disk. Some contributed stars to the halo. Some delivered gas that later cooled into the more orderly rotating disk, where younger generations of stars would form. The Milky Way was not born mature, it was battered into maturity. This is where our intuition usually fails a second time. We tend to picture growth as additive, as if the galaxy simply gathered more and more material while remaining fundamentally itself. But early on, there was no finished self to preserve. The Milky Way did not sit at the center of a stable identity, while the universe handed it resources. The galaxy's identity emerged through the very process of absorbing, mixing, and surviving repeated disruption. The distinction between building and damage had not yet cleanly separated. In a deep sense, the Milky Way became itself by enduring things that could have prevented its final form altogether. That is why the phrase galactic cannibalism is vivid but incomplete. It captures the violence of one system swallowing another, but it can make the process sound like a late-stage behavior of already finished galaxies. In reality, for systems like the Milky Way, feeding is not merely what happens after formation. Feeding is part of formation. Before the Milky Way could become the serene barred spiral we inhabit, it had to pass through eras when serenity was not available. Matter was arriving, colliding, settling, and being reworked. Some stars formed early and were later thrown into hotter, thicker orbits. Some gas lost energy and flattened into the embryonic disk. Some substructures survived for a while, only to be stripped apart on later passages. The galaxy was not just getting bigger, it was negotiating what kind of galaxy it would become. This is where the science acquires an emotional weight it does not announce. Because it means home was not assembled under peaceful conditions. The sun was not present for those earliest episodes, but the structure that eventually made the sun possible was shaped by them. The calmness we now project onto the Milky Way is retrospective. It is the illusion that emerges when you arrive late in a process and mistake the current phase for the whole history. Imagine walking into a city at dawn, after centuries of war, collapse, rebuilding, annexation, migration, and redesign, and assuming it must always have looked this coherent because this is the form in which you encountered it. That is roughly how human intuition misreads the galaxy. We see the present order and forget that order is often what a long violence looks like after enough time has passed. The Milky Way's disk, in particular, tempts that misunderstanding. A rotating disk has grace, it has apparent simplicity. Its stars move in broadly organized orbits. Spiral structure gives the eye something to follow. Dust lanes add contour. It feels like a design. But disks are fragile things, or at least, they are harder to maintain than our visual habits suggest. Repeated mergers can thicken them, disturb them, distort them, or delay their formation. For a galaxy to end up with a broad, rotating stellar disk, like the Milky Way's, a great deal had to happen correctly, and a great deal had to stop happening with the same intensity. The galaxy had to survive enough early growth to become massive, but also avoid being so violently disrupted later that no stable disk could settle or persist. In other words, the Milky Way is not just the product of feeding. It is the product of feeding at a survivable rhythm. That balance matters. Too little accretion, and there is not enough material to build a large spiral galaxy. Too much late chaos, and the disk never attains the relative stability required for long-term star formation on the scale we observe. The galaxy we know is the consequence of both appetite and restraint, though restraint here does not mean mercy. It means a change in tempo. The most formative violence belongs disproportionately to earlier times, when assembly was faster and the universe itself was denser, closer, more collision-prone. That early tempo left marks we still live inside. Some of those marks are structural, the existence of the stellar halo, the thick disk, the kinematic memory preserved in older stars. Some are chemical, early generations of stars forged heavier elements, exploded, and enriched later gas from which new stars and planets could form. Some are dynamical, material from past mergers altered orbits, redistributed angular momentum, and helped define how later generations of matter would settle. A galaxy remembers with motion. It remembers with composition. It remembers with shape. And the Milky Way is full of such memory. The most powerful thing about that memory is that it is not merely archaeological. It is not only telling us what once happened and then ended, it is telling us what kind of process the galaxy fundamentally is. Once you understand that its visible order emerged from repeated capture and restructuring, the present-day Milky Way stops looking like an exception to cosmic violence and starts looking like its refined continuation. What has changed is not the principle. What has changed is the pace, the scale, and the visibility. The young Milky Way fed in rougher conditions. Smaller systems fell in more often. Major rearrangements were more common. Over time, as the galaxy became larger and the local environment thinned, the rate and character of growth shifted. The violence did not vanish. It became more selective, less like a storm of assembly, more like a long inheritance of smaller victims, lingering gas streams, and future collisions already set on their course. That transition is one reason the modern Milky Way can feel deceptively calm. We are living after the fiercest architectural phase, but not after the process itself. The galaxy has left its most formative youth, yet it remains metabolically active. It still turns gas into stars. It still captures and strips satellites. It still reorganizes matter. It still exists inside a hierarchy of gravity larger than the bright disk suggests. And that means the bones of its earlier meals have not disappeared. They are still there, faintly orbiting above and through the more luminous galaxy we call the Milky Way. Not as scenery, but as evidence. The halo is where the old violence goes when it does not fully vanish. It does not announce itself the way the galactic disk does. It does not sweep across the sky in one luminous band. It does not offer the eye an obvious shape to admire. The halo is too sparse for that, too diffuse, too patient. Its stars are scattered in a vast volume surrounding the Milky Way, moving on long, often tilted or elongated orbits, far less orderly than the broad circular flow that gives the disk its calm appearance, which is exactly why the halo matters. The disk is where the Milky Way looks composed. The halo is where it confesses. If you only knew the galaxy through the disk, you might imagine a system that has always possessed this basic symmetry, a central bulge, a rotating plane, spiral structure, organized motion, but the halo preserves a different kind of truth. It preserves the debris field. It preserves the material that never fully settled. It preserves stars that were born elsewhere, under different conditions, inside systems that no longer exist as separate galaxies at all. This is where the Milky Way stops looking like a single object and starts looking like layered history. Because the halo is not just old stars around the galaxy. That phrase is technically defensible and emotionally useless. The halo is a vast archive of acquisition, a place where ancient mergers, disrupted dwarf galaxies, and dynamically heated stellar populations leave traces long after the visible drama is over. Some of those stars formed in the Milky Way's own early turbulence and were later kicked into hotter, thicker orbits. Others were imported, delivered by smaller galaxies that fell in, were stripped apart, and dissolved into the larger structure. The halo is not background. It is inheritance. And what makes that inheritance so haunting is that it survives in fragments, not neat labeled components, not clean before and after diagrams. What survives are clues. Stellar motions that do not match the calm spinning of the disk, populations with unusual chemical signatures, long streams of stars stretched out across the sky like torn fabric, over-densities that hint at swallowed systems whose coherence failed billions of years ago. A galaxy does not digest cleanly. That is one of the strangest things about gravitational consumption. In biological life, digestion tends toward dissolution. Food loses identity rapidly. But galaxies consume at such low densities and over such immense spans of time that the remnants can linger as structures of memory. Long after a smaller galaxy has ceased to exist as an intact, self-governing system, its stars may still travel together for a while, preserving in their shared motion the ghost of a body that is already gone. The Milky Way is full of such ghosts. And once astronomers learned how to read them, the halo changed from a vague outer region into a crime scene with surviving evidence. One of the most important breakthroughs in this story came not from seeing more light, but from measuring motion more precisely. Because to understand the halo, it is not enough to know where stars are. You need to know how they move. Motion reveals family resemblance long after shape has dissolved. Stars that were once part of the same disrupted system can still carry similar orbital signatures, similar velocities, similar trajectories through the larger gravitational field. This is why modern surveys transformed our understanding of the galaxy. They did not merely give us a prettier map, they made the Milky Way kinematic. They turned the galaxy from a photograph into a dynamic reconstruction. Suddenly, stars were not just points, they were evidence vectors. Their speeds, directions, and chemical compositions could be used to infer which stars likely formed together, which were accreted from elsewhere, which populations had been heated by ancient mergers, and which visible structures in the halo were not primordial accidents but leftovers of specific events. The galaxy became legible in a new way, not as static light, but as organized aftermath. And that is where the modern picture of the Milky Way becomes almost uncomfortably intimate, because some of the oldest and most consequential episodes in our galaxy's growth are not lost beyond recovery. They are still written into the stars above and around us. The stellar halo contains populations that appear to be the remnants of ancient mergers, systems massive enough to alter the Milky Way's development. systems whose stars now occupy orbits very different from the younger, colder populations of the thin disk. These stars move like memory under tension. They carry the record of earlier impacts, earlier captures, earlier rearrangements. Some belong to structures that have been stretched so thoroughly that only large statistical patterns reveal their common origin. Others survive in more dramatic forms, streams so extended that they arc across enormous portions of the sky, thin enough and coherent enough to reveal that a once-bound stellar system was drawn out, passage after passage, into a gravitational filament. A stellar stream is one of the most beautiful and merciless things in astronomy. Beautiful because it is delicate, a faint line of stars preserving motion across colossal distances. Merciless because it exists only because something failed to remain whole. This matters for more than tone. It matters because the halo tells us that the Milky Way did not merely grow once, in some chaotic youth, and then settle forever. The halo shows that growth by disruption leaves durable traces. It shows that accretion is not a theory layered on top of the galaxy as an interpretive flourish. It is carved into the galaxy's outskirts as structure. And some of those structures are old enough to remind us of a harder truth. When we say the Milky Way devours galaxies, we are not only describing a present behavior, we are describing the dominant logic by which large galaxies become large at all. The halo is where that logic remains visible. Consider the emotional difference between two pictures. In the first, the Milky Way is a majestic city of stars, surrounded by a faint, mostly irrelevant periphery. In the second, the bright disk is only the central concentration of a larger system whose outskirts are strewn with remains, imported stars, partially digested satellites, tidal debris, chemically distinct populations, and kinematic scars from impacts that altered the whole galaxy. The first picture is scenic. The second is true. And truth here does not reduce beauty. It changes the temperature of it. The Milky Way becomes more elegant, but also colder, more coherent, but less innocent. Its grace is no longer the grace of untouched order. It is the grace of a structure that survived repeated restructuring and still carries the marks. That distinction becomes even sharper when you think about timescale. A human lifetime is too short to feel the halo changing. Even civilizations are too short. The streams barely seem to move. The outer stars barely seem to drift. The remnants of ancient mergers appear almost timeless. But that sensation of timelessness is only what violence looks like after it has been stretched across billions of years. Tidal stripping, phase mixing, orbital diffusion, these are not dramatic in the human sense. They are not loud. They do not need to be. The universe can destroy a galaxy without ever raising its voice. That is why the halo is such a powerful corrective to intuition. It makes visible a category of event that human psychology is bad at recognizing. Not explosion, but erasure by persistence. A smaller galaxy falls in. It survives one passage, then another. Stars are stripped away. Its shape deforms. Its center weakens. Its outer layers become streams. Its orbit continues. More mass is lost. More coherence fails. Eventually, the separate object is no longer truly a separate object. What remains is distributed memory. And the Milky Way grows a little more complete. Or rather, complete in the only sense galaxies ever are, by becoming a larger process made out of many ended ones. This is where the moral geometry of the galaxy changes. We usually reserve words like devour for sudden, obvious destruction. But a galaxy devours by dissolving boundaries over time. It makes other systems into itself not through one final moment, but through a long sequence of gravitational decisions. Each orbit tightens dependence. Each stripping event transfers identity. Each stream is a sentence in the same argument. What enters this deeper structure does not leave unchanged. And the halo keeps that argument in view. It also reveals something subtler. Not every consumed system contributed in the same way. Some mergers were massive enough to reshape the Milky Way's internal structure, heating stars and altering the disk. Others were minor, adding stars to the outskirts with relatively little disturbance to the inner galaxy. Some delivered gas that later became part of new star-forming regions. Some mostly contributed dark matter and old stars. Some were almost entirely erased. Some are still in the process of being erased. This variety matters because it keeps the story honest. The Milky Way did not grow through one kind of event repeated endlessly at one scale. It grew through a hierarchy of encounters, some formative, some incremental, some ancient and partly obscured, some recent enough to trace in exquisite detail. The galaxy's history is not a single wound. It is a layered accumulation of injuries, absorptions, and recoveries, which is why the halo feels so different from the disk. The disk says, this system rotates. The halo says, this system remembers. And if the halo is memory, then one question begins to sharpen inside it. Memory of whom? Not in the sentimental sense, not as though the galaxy mourns what it absorbs, but in the forensic sense. Which specific victims can still be identified? Which remnants are ancient enough to have shaped the Milky Way's overall structure? Which streams are the still visible skeletons of systems that once fell into our galaxy and never came back out? That question leads toward one of the most remarkable discoveries in galactic archaeology. Because among all the diffuse testimony in the halo, some events stand out as more than faint historical texture. Some mergers were not mere background growth. They were structural episodes, encounters large enough to help define the Milky Way we now inhabit. One of them appears to have left stars on highly radial orbits, evidence of an ancient collision substantial enough to change the galaxy's architecture. Another left entire families of streams wrapping through the halo. And one, unlike the ancient catastrophes reconstructed from distant memory, is still close enough, clear enough, and unfinished enough that we can watch its destruction as an ongoing fact. The halo does not just contain old bones. It contains a body still dying. That is the moment when the Milky Way stops feeling historical and becomes present tense. Up to this point, the violence can still hide behind scale. Ancient mergers, fossil streams, kinematic scars, imported stars scattered so widely across the halo that they have to be reconstructed through motion and chemistry. All of that is real, but it can still feel abstract, like reading the record of a war so old that no living witness remains. Sagittarius changes that. Because Sagittarius is not only evidence that the Milky Way once grew by devouring smaller galaxies, it is evidence that the same logic is operating now, in a form so clear that the galaxy's appetite becomes impossible to soften into metaphor. The Sagittarius dwarf spheroidal galaxy is a small satellite of the Milky Way. Or, rather, it is the remnant of one. That distinction matters. We tend to speak of dwarf galaxies as if they are tidy miniature versions of larger systems, self-contained little islands orbiting a greater host. But Sagittarius has already crossed beyond that simplicity. It is not merely orbiting the Milky Way. It is being dismantled by it. Every time it passes through the Milky Way's gravitational field, especially near the disk and inner halo, the difference in gravitational pull across its extent tears more of it away. Stars that once belonged to Sagittarius are stripped and flung along its orbit, forming enormous tidal streams that wrap around the galaxy. Some of that debris extends so far across the sky that, from the right perspective, the remains of Sagittarius are less like a satellite and more like a wound drawn around the Milky Way itself. This is what galactic death looks like when gravity is patient. No explosion, no sudden disappearance, just structure failing a little more on every pass. And that patience is what makes it so powerful. Human intuition expects destruction to be obvious, fast, catastrophic. It expects an event with a before and after. Sagittarius offers something harder to emotionally process. A death that is distributed across orbital time, where the object remains partially itself while steadily losing the possibility of remaining itself for much longer. There is something almost surgical about tidal stripping. Gravity does not need to crush a galaxy outright. It only needs to make the outer regions less securely bound than the path they are trying to follow. Once the Milky Way's field overwhelms the local self-gravity holding Sagittarius together, stars begin to peel away. Some drift ahead of the remnant along its orbit. Some trail behind. Over time, the galaxy is stretched into a stellar stream, a structure that still remembers its origin but no longer possesses the compact coherence of the thing it used to be. A galaxy can remain visible after its integrity is already gone. That is one of the coldest truths in this story, because it means visible survival is not the same as structural survival. Sagittarius still exists in the conversational sense. We can point to its remnant, we can name it, we can describe it as a satellite galaxy. But in the deeper dynamical sense, it has already crossed into another category. It is no longer simply itself. It is becoming Milky Way material. That transformation is not poetic language. It is orbital fact. The stars stripped from Sagittarius do not vanish into philosophical symbolism. They become part of the larger gravitational inventory of the Milky Way. They move through its halo. They contribute to its streams, its outskirts, its layered memory. Their previous home becomes less and less recoverable as a self-contained object. The galaxy that falls in does not just lose mass. It loses authorship over its own matter. And this is the point where the phrase "our galaxy" starts to acquire a darker meaning. Because the Milky Way is not merely a place that contains stars. It is a system that claims them. It takes stars formed elsewhere, under other histories, in other gravitational homes, and turns them into part of its own extended body. Sagittarius is one of the clearest cases because the evidence is so rich. Its stellar streams have been mapped across the sky. Their positions, motions, and compositions reveal repeated orbital passages and repeated loss. Models of its disruption show a long interaction history with the Milky Way, likely spanning billions of years. It may once have been more massive than the remnant we observe now. It may have carried more stars, more dark matter, more internal coherence than it retains today. What we are seeing is not the full object at its height. We are seeing what is left after the Milky Way has been working on it for a very long time. There is a brutal elegance to that phrase, working on it, because that is how a large galaxy consumes, not with one decisive impact, but through repeated exposure to a deeper gravitational field. A dwarf galaxy falls in. Its dark matter halo is stripped. Its outer stars are loosened. Its orbit changes. It passes again. More material is lost. The remnant shrinks. Its own gravity weakens. The next passage becomes more damaging than the last. Eventually, the distinction between remnant and debris becomes increasingly unstable, and the galaxy survives more as a stream and a memory than as an independent world. Gravity reduces by iteration, says Devours. And once you understand that, Sagittarius stops being a side story. It becomes the perfect bridge between the Milky Way's ancient history and its ongoing present. It proves that the halo is not merely a museum of long-finished mergers. It is also an active work site. The same mechanics that built the galaxy through early accretion are still operating, though now at a slower tempo and on smaller prey. This is the midpoint shift in the entire story. Until Sagittarius, it is still possible to imagine that the Milky Way's devouring behavior belongs mostly to its youth, something formative. Yes, but largely complete. Sagittarius removes that comfort. It tells us the galaxy is not merely shaped by an old appetite. It still possesses one. The Milky Way is not done absorbing. And once you see one victim clearly, you begin to suspect how many other processes are hidden in quieter forms around it. Because stars are only the visible part of this exchange. Sagittarius gives us starlight to trace. That makes the violence legible. But stars are not the only thing a dwarf galaxy brings when it falls into a larger host. It also carries dark matter. It may carry gas, depending on its history and how much has already been stripped. It contributes gravitational disturbance. It perturbs the structure it passes through. Its repeated plunges through the Milky Way may even have helped stir the disk, warp outer regions, or influence episodes of star formation indirectly by rearranging material and altering local conditions. A swallowed galaxy does not simply add mass. It alters the host that consumes it. That matters because it destroys one last simplifying image. The idea that galactic cannibalism is a clean act in which a larger system takes in a smaller one while remaining unchanged in essence. In reality, even asymmetrical encounters leave marks. The victim is transformed more completely, of course, but the host is not untouched. The passage of Sagittarius through the Milky Way has likely left dynamical signatures behind it. The larger galaxy remains the winner, but winning still means being affected. Consumption is also interaction. This is part of why galaxies feel so much more alive once you stop thinking of them as pictures. A galaxy is not just shining matter arranged in a shape. It is a dynamical ecosystem of gravity, gas, stars, dark matter, orbital memory, and delayed consequence. One encounter can echo through many components. A passing dwarf can leave streams in the halo, perturb stars in the disk, alter the distribution of matter, and participate in a history whose visible consequences may only become obvious much later. Nothing arrives alone. And this is exactly why the next step in the descent matters. Because once we admit that the Milky Way is still feeding on smaller galaxies, another question becomes impossible to avoid. If the galaxy keeps turning matter into stars, and keeps absorbing stars from outside, and keeps growing through infall, then where is all of that future structure really coming from? Sagittarius answers one part of that question with great clarity. It shows us the theft of stars already made. But stars are expensive. They take time. They require cold, dense gas. They are the bright end of a longer chain. If the Milky Way were only inheriting finished stars from victims like Sagittarius, that would not be enough to explain the full continuity of its life. The galaxy would still face a deeper problem. Star formation consumes gas, and over cosmic time, a galaxy that keeps making stars should deplete the raw material required to keep doing so. In other words, even a predator can starve. And if the Milky Way is still alive in this active sense, still luminous, still forming stars, still renewing parts of itself instead of merely fading, then the real mystery lies below the visible violence. Not how it steals stars. Because stealing stars is only half the story. A galaxy can absorb another galaxy and inherit part of its stellar population. It can add debris to the halo. It can grow its outskirts through stripped streams and accreted remnants. But stars are not a renewable resource in the simple sense. They are a finished phase of matter. Beautiful, luminous, long-lived, sometimes spectacular in death, but already committed. If the Milky Way were living only off inherited stars, it would be a curator of old light, not an engine still capable of renewal. And yet renewal is exactly what we see. The Milky Way is not just preserving ancient stars, it is still making new ones. Across its disk, clouds of cold molecular gas continue to collapse. Young stellar populations continue to appear. Nebulae continue to glow where radiation from newly formed stars lights and sculpts the gas around them. This is not the behavior of a galaxy that has simply assembled what it has and is now spending down the remainder in dignified decline. Something is replenishing it. Or, at the very least, something has been replenishing it long enough for the galaxy to remain active far beyond what a simple closed-box picture would allow. This is where the Milky Way becomes stranger again, because star formation looks, at first glance, like a self-contained process. We see a dark cloud. We see a region of collapse. We see stars ignite. The visual logic feels local, almost intimate. A part of the galaxy turns inward under gravity, and light appears. But the local event only makes sense inside a larger supply chain. Molecular clouds do not emerge from nowhere. Dense star-forming regions are the final compressed knots of a much longer movement of matter through the galaxy. A star is what fuel looks like at the end of its journey. Long before fusion starts, gas has already been cooling, mixing, circulating, settling, and crossing thresholds. Some of it may have been enriched by earlier generations of dead stars. Some of it may have been pulled inward from larger galactic radii. Some of it may have descended from the halo above the disk. Some of it may have originated outside the Milky Way's bright stellar body altogether, arriving as part of a stream, a cloud complex, or a broader inflow from the galaxy's surrounding environment. By the time the sky glows with a newborn cluster, the deeper logistics have already been running for ages. And that creates a mathematical discomfort. Because if you take the Milky Way's present-day star formation rate and compare it to the amount of cold gas available in the disk, the galaxy should not be able to keep this up forever without replacement. The exact accounting depends on which gas phases you track and how efficiently gas cycles between them, but the broad conclusion is clear. Star formation consumes its own conditions. Gas that collapses into stars is no longer free to behave like diffuse fuel. Some fraction is returned later through stellar winds and supernovae. Yes, but not all of it. Not immediately. And not in the same form. A galaxy that keeps building stars must either slow down, recycle extremely effectively, or draw from reservoirs larger than the visible star-forming disk suggests. The Milky Way appears to do all three, but the third part is what gives the whole story its deeper shape. The galaxy is not sealed. That sentence should land harder than it first appears to. We often picture galaxies as bounded systems, a visible disk inside a visible edge, maybe with a halo of stars around it, all floating as a self-contained island in intergalactic darkness. But the Milky Way is not a closed island. It is immersed in a much larger gaseous environment. Around the bright disk lies a vast, diffuse, extremely hot corona of gas. A halo, not of stars this time, but of plasma, thin and hard to detect directly, extending far beyond the familiar band of light. The galaxy has an atmosphere. Not an atmosphere like Earth's, dense enough to breathe or blue enough to see, something stranger. A gigantic, almost ghostly envelope of hot ionized gas filling the space around the Milky Way, thin enough to evade ordinary sight, but massive enough to matter. It is one of the least intuitive features of our cosmic home because it violates the visual grammar we instinctively apply to galaxies. The eye looks for edges, the physics gives us gradients, the eye looks for a clean object, the physics gives us layered phases of matter reaching far into the dark. And inside that larger environment, gas moves. Some of it cools, some of it mixes with material launched outward from the disk, some of it falls inward, some of it is torn from satellites and fed into the Milky Way's wider structure before ever reaching the regions where stars can form. This is where the galaxy starts to resemble weather again, but on a scale so large that the comparison almost fails under its own weight. There are fountains of gas driven upward by stellar feedback, winds, radiation, and supernova explosions injecting energy into the interstellar medium. Some of that material eventually cools and rains back down. There are high-velocity clouds moving through the halo, some likely representing infalling material, some part of complex circulation between disk and corona. There are immense gaseous streams associated with the Milky Way's satellite system, including matter stripped from the Magellanic Clouds, tracing possible future fuel supplies on scales so vast that cloud feels like a childish word for them. The galaxy is not only forming stars, it is managing a hydrology of fire. That hydrology matters because it changes the meaning of continuity. A galaxy can appear stable while undergoing enormous internal and external cycles of matter. Gas can be ejected from the disk and later reaccreted. Halo material can cool into denser structures. Satellite interactions can contribute fresh gas. The corona itself can act as a reservoir, though an imperfect and complex one, mediating how material enters, circulates through, and leaves the star-forming regions below. This is not a machine in the engineered sense. There is no central control, no designed efficiency. The Milky Way is a self-organizing gravitational and thermodynamic system, and like all such systems, its order emerges from constant negotiation between competing tendencies. Gravity wants concentration. Pressure resists it. Feedback reheats or disperses gas. Cooling allows collapse. Rotation redistributes matter. Magnetic fields complicate local dynamics. Dark matter shapes the deeper potential. Satellite encounters disturb the whole arrangement from outside. And out of this argument, stars keep appearing. That is the miracle, if the word is used carefully enough. Not miracle as an abandonment of explanation. Miracle as the recognition that a lawful universe can still produce structures of astonishing persistence. The Milky Way should not feel static once you understand how much has to keep happening underneath its visible calm. Fuel must move, heat must be shed, turbulence must fluctuate, clouds must condense, gravity must win locally even while larger feedback processes threaten to interrupt it. Star formation is not the default state of gas. It is the visible victory of a very particular set of conditions. A star is a successful bottleneck. Everything before it is transport, cooling, compression, and survival. And this is why the galaxy's future can never be read simply from the stars it already has. To know whether the Milky Way remains alive in the generative sense, you have to ask a more difficult question. How long can the underlying fuel economy continue? How much gas remains? How much can be recycled? How much can be drawn in from the halo? How much can arrive from stripped satellites? How efficiently can hot material cool into the denser phases required for later collapse? How much of the galaxy's present luminosity is actually the delayed expression of inflows that happened long ago? The visible present is always lagging the hidden supply chain. That lag creates one of the most haunting aspects of galactic life. When we look at the Milky Way and see a galaxy still capable of star formation, we are not just seeing what the galaxy is now. We are seeing the consequence of earlier success in acquiring and retaining fuel. Some of the light we admire is the late flowering of material whose inward journey began far from the place where it finally turned into stars. Which means the present-day beauty of the galaxy is partly inherited from transactions we did not witness. Gas that fell, gas that cooled, gas that survived feedback, gas that crossed from halo to disk, gas that was once outside the luminous Milky Way entirely. And suddenly the phrase "devours galaxies every single day" acquires a wider meaning, because the Milky Way is not only consuming finished stellar systems, it is also drawing in the raw conditions of future light. Some of that comes from its own internal recycling, some comes from its extended gaseous halo, some may arrive attached to smaller companions, stripped and redistributed long before becoming visible in any spectacular way. The appetite is not just for stars. It is for possibility. That is the harder thing to feel emotionally, because possibility has no obvious outline. Streams of stars are photogenic. Dying dwarf galaxies make for dramatic language. Hot, diffuse gas does not. But if the galaxy's feeding were reduced to the theft of old stars, the Milky Way would eventually age into quiet accumulation. The reason it still has an active luminous future is that it can continue converting inflow into creation. The violence becomes light. And once you understand that, one more unsettling truth emerges. The galaxy does not merely remember earlier death in its halo. It continuously translates death, capture, and infall into the conditions for later birth. Matter stripped from smaller systems, gas expelled by older stars, plasma circulating through the corona, enriched material returned by stellar explosions. All of it enters a long chain of transformation. The galaxy feeds on ended structures to produce new ones. Its metabolism is historical. Its future is made of ruin. That is why the Milky Way cannot be understood as a static island of stars. It is more like a layered engine of inheritance, one in which matter changes role without ever leaving the argument. Today's halo debris can become tomorrow's diffuse reservoir. Yesterday's supernova ash can become part of a future cloud. A satellite's stripped gas can become fuel for stars that do not yet exist. The bright disk is not a final destination. It is one phase in a larger circulation. And every circulation raises the same question in a sharper form. If the galaxy lives by moving fuel through these hidden reservoirs, then where does the deepest reserve sit? Not the stars we can count, not the clouds we can photograph, but the great surrounding mass of gas through which all of this future must pass. Above the Milky Way's shining disk, there is an invisible ocean, and some of our future stars are already falling through it. This is where the galaxy becomes hardest to picture honestly, because almost everything the human eye wants from an object disappears. There is no bright boundary, no clean silhouette, no obvious motion, just an immense surrounding medium, hot, rarefied, ionized gas extending far beyond the visible disk, threaded with inflows, disturbed by outflows, mixed by turbulence, shaped by gravity, and slowly participating in the long conversion of diffuse matter into future structure. If the stellar halo is where the Milky Way remembers, the gaseous halo is where it waits. That waiting is not passive, it is thermal, dynamical, unstable in places, and deeply consequential. The corona surrounding the Milky Way is so hot that much of it does not resemble the cold. dense gas from which stars directly form. It is a different phase of galactic existence, thinner, harsher, harder to collapse. And yet, that does not make it irrelevant, quite the opposite. It makes it the great intermediate territory through which matter must often travel before becoming part of the luminous disk below. The galaxy lives under a sky of delayed possibility. This is one of the most profound reversals in the whole story. We begin with a galaxy that looks like a concentrated structure, stars gathered into a disk, light arranged into a form. But the deeper truth is that much of its future is suspended in regions that do not yet look like the galaxy at all. A reservoir can be part of a system long before it resembles the system's visible identity. Matter can be gravitationally associated, thermally trapped, and dynamically relevant long before it settles into the colder, denser states that the eye recognizes as meaningful. In other words, the Milky Way's future enters the galaxy before it becomes visible as future. And this is why gas accretion feels so philosophically strange. A galaxy can be growing in a real sense even when the growth has not yet crossed into starlight. Material can be entering the wider halo, mixing with the corona, cooling in patches, raining inward, or arriving as stripped debris from satellites, all without offering the viewer the emotional satisfaction of a clear event. The universe does not mark the threshold for us. It simply keeps moving matter across it. Some of the most revealing signs of this come in the form of high-velocity clouds, concentrations of gas observed moving through or toward the Milky Way's halo at speeds and trajectories that suggest complicated relationships to the larger galaxy. Some may be infalling material from the halo or beyond. Some may be recycled gas launched upward from the disk and now returning. Some may carry the chemical fingerprints of prior processing, telling us they are not pristine in the naive sense, but already part of a longer chain of galactic metabolism. These are not just clouds. They are arguments in motion. Each one asks the same question in a different dialect of matter. Where did this gas come from? What state is it in? What will happen to it next? And how much of the galaxy's future is passing through forms that the naked sky would never teach us to notice? Then there is the Magellanic Stream, one of the grandest examples of how satellite interactions can load the Milky Way's environment with future consequence. Trailing from the large and small Magellanic Clouds is an enormous ribbon of gas, stretched across a huge fraction of the sky, likely drawn out through tidal forces and hydrodynamical interaction. It is too big, too diffuse, too spatially extended to feel intuitive. Stream is accurate, but it almost understates the scale of it. This is not a local feature. It is a continent of gas in motion, and in that motion lies a future. Not all of it will become part of the star-forming disk. Not all of it will survive in a simple path inward. Interactions with the hot halo can disrupt, heat, mix, or partially dissolve incoming material. Some of it may feed the corona before feeding the disk. Some may fragment. Some may never reach the dense states required for star formation in any straightforward way. The science here is not neat, and it should not be narrated as if it were. Gas accretion is one of those domains where explanation becomes more honest when it preserves complexity rather than flattening it into a pipeline. But the overall direction is clear enough to matter. The Milky Way is embedded in and interacting with vast gaseous structures that can contribute to its long-term fuel economy. The galaxy is not a sealed disk under empty space. It is a luminous layer inside a much larger circulation. That circulation also includes feedback from below. Stars do not merely consume fuel and vanish into passive existence. Massive stars drive winds. Supernovae inject energy and momentum into surrounding gas. Radiation fields alter ionization states, temperatures, and pressure balances. The disk pushes material upward even as gravity and cooling try to pull material back down. Gas can rise in galactic fountains, arc into the lower halo, mix with hotter ambient material, and later return in altered form. So the Milky Way does not simply receive fuel. It churns it. This is why the word weather keeps returning, even though it is an inadequate metaphor. Weather suggests localized fluctuation within an atmosphere. Galactic gas cycling is slower, larger, and governed by different dominant physics. But there is a shared emotional truth between them. What looks stable from a distance is maintained by constant movement, beneath the appearance of calm. Matter is rising, cooling, falling, dispersing, and gathering again. The sky above the disk is busy with things the eye cannot see. That line is not ornamental. It is almost the central emotional lesson of the Milky Way itself. The visible galaxy has always been a partial truth, and nowhere is that more evident than in its gas. What feeds future stars often passes through invisible phases. What determines long-term star formation often resides in hot, diffuse, difficult-to-map structures. What matters most is frequently not what is brightest, but what is most continuously involved in the transfer of possibility from one phase of matter to another. A galaxy lives by phase changes. Cold molecular gas becomes stars. Stars return enriched material to the interstellar medium. Feedback drives some gas upward. The halo stores, mixes, and mediates. Infall continues. Cooling resumes. Collapse begins again. And because this cycle is imperfect, the details matter. Gas can be lost. Heating can stall collapse. Interactions can redistribute fuel rather than delivering it cleanly. The corona can act as reservoir and barrier at the same time. The same structure that stores future possibility can also delay it. This is part of what gives the galaxy its severe elegance. The Milky Way is not efficient in the engineered sense. It is persistent in the cosmological sense. It does not solve its fuel problem once. It keeps negotiating it. The visible stars are what successful negotiations look like. Which means the galaxy's beauty is not the beauty of abundance alone. It is the beauty of throughput, of matter repeatedly surviving enough obstacles to become luminous. That should change the emotional meaning of star fields. A bright region of the Milky Way is not just a concentration of stars. It is evidence that cooling beat heating somewhere, that collapse beat turbulence somewhere, that enough gas reached the right density under the right conditions for gravity to win again. Every generation of stars is a local verdict reached inside a much larger argument. And that argument is not only internal. Because the Milky Way's gaseous environment is shaped partly by the same satellite interactions that give us stellar streams and halo debris, smaller galaxies do not merely donate stars when they fall in. They can also donate or lose gas, disturbing the halo, enriching it, loading it with future material, or complicating the path by which future material reaches the disk. The distinction between accretion from outside and circulation from within can become blurred, because once matter enters the wider halo, it becomes part of a shared environment of mixing, heating, cooling, and delayed reuse. A galaxy digests in phases. Some of those phases shine, some do not, but all of them belong to the meal. And this is where the central thesis deepens into something sharper than appetite. The Milky Way does not just devour galaxies and collect trophies. It reorganizes matter across states. It turns capture into reservoir, reservoir into infall, infall into cloud, cloud into star, star into ash, ash into future cloud again. What looks like violence in one era becomes fertility in another. What looks like loss at one scale becomes supply at another. Its order is built from conversion. That is why home is such a misleading word for the Milky Way if we use it carelessly. Home implies enclosure, stability, a finished boundary separating inside from outside. But the galaxy is porous. Matter crosses its wider threshold. Satellites feed it, gas leaves and returns. The visible disk depends on structures extending far beyond what the eye would call the galaxy proper. Even the line between acquisition and self-renewal becomes unstable. So much of the Milky Way's continuity comes from not being closed. The galaxy survives by remaining open to matter it has not yet become, and there is something quietly unsettling in that. Our intuition prefers finished things. It prefers a world in which identity is built by containing itself. But the Milky Way persists by exchange. It remains a live structure because it can continue drawing from reservoirs beyond its bright body. Its future is not held entirely in its current stars. Its future is distributed through the dark around it. Once that sinks in, another feature of the galaxy begins to change character as well. The center, At first, the galactic center seems like the obvious place to imagine appetite. Dense, bright, crowded, gravitationally severe. If anywhere in the Milky Way should reveal the purest form of consumption, it would be there. And in one sense, that is true. Buried there is a black hole millions of times the mass of the Sun, Sagittarius, a star, quiet by the standards of active galactic nuclei, but quiet in a way that feels conditional rather than harmless. Because the deepest mouth in the Milky Way does not need to be loud to matter. It only needs to be waiting. At the center of the Milky Way, buried behind dense curtains of dust and crowded fields of stars, sits Sagittarius, a star, a supermassive black hole with a mass of about 4 million suns. That number is easy to say and hard to feel. 4 million suns compressed into a gravitational object so compact that, once matter crosses a certain boundary, no signal can return, no light, no warning, no last visible shape. And yet, for all that severity, Sagittarius. A star is not currently blazing like the monstrous black holes at the centers of some other galaxies. It is comparatively quiet, not silent, never truly silent, but quiet enough that if you judge the Milky Way only by present brightness, you might mistake its center for a stable core rather than a dormant appetite. That would be another false stillness. Because black holes do not become harmless when they become dim. They become conditional. Their violence depends on supply. A black hole shines not because it is intrinsically luminous, but because matter falling toward it can form an accretion flow, heating to extraordinary temperatures as it spirals inward, radiating energy before crossing the event horizon. No fuel, no blaze, less fuel, less blaze, but the structure remains what it is. A sleeping machine is still a machine. This matters because the Milky Way's center forces one more correction to human intuition. We tend to imagine the black hole as the obvious master of the galaxy, the thing doing the holding, the thing making the Milky Way possible. But that is not true in the large-scale sense. Sagittarius. A star does not dominate the dynamics of the whole galaxy. The dark matter halo matters far more for the Milky Way's overall mass budget and large-scale structure. The black hole rules its own immediate neighborhood with terrifying authority. But most of the galaxy lives far outside that intimate zone of control. And that makes the center stranger, not smaller. Because Sagittarius, a star is not the reason the Milky Way exists. It is the concentrated reminder that the galaxy contains forms of gravity that become more severe the deeper you go. The outer halo teaches us that the galaxy is held by hidden mass. The center teaches us that, under the right conditions, hidden mass can collapse into something from which return is impossible. The galaxy is a hierarchy of inescapability. And near the center, that hierarchy tightens. We know Sagittarius A star is there, not because we have seen the black hole itself as an object in ordinary light, but because we have watched stars move around an apparently empty point with impossible speeds and tight orbital curves. The famous star S2, for example, sweeps around the galactic center on an orbit that makes the conclusion unavoidable. There is an extremely compact mass there, too concentrated to be a cluster of ordinary stars, too stable in its compactness to be anything gentler. Motion convicts what light cannot show. That phrase has been true for the Milky Way all along. It was true for the dark matter halo. It is true again here. The eye gives us a crowded central region, thick with stars and obscured by dust. Physics gives us the deeper verdict. There is a black hole at the core, and its existence changes the moral atmosphere of the galaxy even when it is not loudly feeding. Because quiet is not the same as inactive forever. There is evidence that Sagittarius A star was more active in the past than it is now. The central black hole appears to have experienced stronger episodes of accretion, brighter phases during which more matter reached the inner regions and more energy was released outward. The Milky Way does not host a quasar-like nucleus today, but it may not have been this subdued across all of its history. Some observed structures and radiation signatures suggest the center has flared more significantly in the relatively recent cosmological past. The center remembers hunger too, and that possibility changes how we think about the whole galaxy. Because if the Milky Way's black hole can move between quieter and more active states depending on fuel supply, then the apparent calm of the center is not a permanent personality trait. It is a circumstance, a contingent expression of current conditions. Feed the black hole more efficiently, alter the inflow of gas, disturb the inner region sufficiently, and the center can brighten. The machine does not need to change its nature. It only needs material. This brings us to an important distinction. The Milky Way devours galaxies primarily through its extended gravitational structure, its halo, its tidal field, its ability to capture, strip, and absorb smaller systems over time. Sagittarius. A star is not the main instrument of that large-scale cannibalism. The black hole is too small, in relative terms, to orchestrate the whole galactic appetite, but it is still part of the same logic of concentration. Matter falls inward, boundaries fail, structure is lost, energy is released. What differs is the scale, the density, and the finality. At the center, appetite becomes absolute. Not because everything in the galaxy ends up in the black hole. Most of it will not. But because the center reveals the limiting case of gravitational possession. In the halo, a dwarf galaxy can be torn into streams over billions of years. In the disk, gas can cool into stars over millions. Near the black hole, once matter enters too far, the future narrows to one direction only. The closer gravity gets to its purest form, the less negotiation remains. And yet the black hole is not simply a cosmic throat swallowing whatever drifts too near. Between the larger galaxy and the event horizon lies a whole sequence of bottlenecks. Gas must lose angular momentum. It must move inward through crowded, turbulent, magnetized, dynamically complicated environments. The journey from matter somewhere in the Milky Way to matter crossing the event horizon is not automatic. This is one reason Sagittarius A star can remain relatively dim even while the galaxy around it is full of stars and gas. Being in a galaxy is not the same as being delivered to the center. There are many ways to orbit without falling. That line matters because it protects the story from melodrama. The Milky Way is not a giant funnel, with everything sliding helplessly into the black hole at its core. Galactic life is more intricate than that. Rotation, turbulence, feedback, stellar dynamics, and the structure of the interstellar medium all complicate inward transport. A black hole can be ravenous in principle and underfed in practice. But underfed is not the same as irrelevant. Sagittarius. A star shapes the central parsecs. It affects nearby stellar dynamics. It participates in the history of the nucleus. It marks the place where the galaxy's gravitational narrative becomes most compressed and unforgiving. And even when it is not dominating the Milky Way as a whole, it functions as a conceptual pressure point. It reminds us that the same universe which builds stars out of cooling gas also permits the existence of regions where matter can be stripped of every visible future. A galaxy is generous at one radius and terminal at another. That is a difficult thing to feel all at once. Perhaps that is why we prefer simpler images. The galaxy as star city, the black hole as monster, the halo as background, the disk as home. Each image isolates one truth and protects us from the full combined architecture. But the real Milky Way does not sort itself into such comforting symbolic roles. It is one connected system. Gas moves through the halo. Stars form in the disk. Satellites are stripped in the outskirts. The center waits under all of it, not as the master of every process, but as the deepest local expression of what gravity can become when concentration is allowed to continue. And once you admit that the center is conditional rather than peaceful, the future of the Milky Way changes tone again. Because the galaxy is not only feeding on small companions now, it is also on a larger trajectory, one so slow that human beings call it future, even though the motion is already underway at this very second. The great neighboring spiral galaxy, Andromeda, is not sitting still. It is moving toward us. The local group is not a collection of static islands, but a gravitationally evolving arrangement whose two largest members are heading toward a merger. Not tomorrow, not soon in any human sense, but already. And that phrase, already, is what matters. Because once you learn to think galactically, Future collision stops meaning an event safely detached from the present. The approach is happening now. Distance is closing now. The orbit of the local group is being written now. The Milky Way's visible serenity is part of a longer sentence that has not reached its verb yet. One day, the galaxy will not merely devour dwarfs and sip from its gaseous halo. One day it will meet an equal, and that changes the scale of everything that came before. Until now, the Milky Way's appetite has mostly been asymmetric. Dwarf galaxies fall in, gas streams are stripped, halo debris accumulates. The host remains the dominant structure, enlarged but not fundamentally overmatched by what it consumes. Even Sagittarius, moving though it is, never threatens to redefine the Milky Way on comparable terms. It is prey entering a deeper gravitational order. Andromeda is different, not because it is infinitely larger, but because it is large enough to matter in the way only a near peer can matter. Another great spiral galaxy, another immense reservoir of stars, gas, dark matter, black holes, history, and future. Another gravitational architecture built through its own long chain of mergers and losses. The Milky Way and Andromeda are not two fixed objects waiting for a sudden collision in a distant age. They are already orbiting within a shared dynamical environment. They are already closing the distance. The encounter has not begun in the visual sense, but in the deeper physical sense, it is underway. The future is already moving toward us. That line sounds dramatic because it is true. Andromeda is approaching at roughly 110 kilometers per second. That speed is not large by the standards of intergalactic orbital motion, but it is enough, sustained across enormous time, to turn separation into inevitability. The exact details of the eventual merger depend on transverse motion, orbital geometry, the distribution of dark matter, and the long exchange of tidal forces as the two galaxies draw closer. But the broad conclusion remains one of the most stable large-scale predictions in the future of the local group. The Milky Way and Andromeda are on course for a transformative encounter billions of years from now. This is not a Hollywood collision. That matters. If narrated badly, galactic mergers become one more victim of human instinct, reduced to the language of impact, as if two solid objects simply smash into each other. But galaxies are not rigid bodies. They are mostly space, mostly diffuse structures governed by gravity across staggering volumes. When two large spirals merge, individual stars almost never collide directly. The violence is not local impact. It is global reorganization. Orbits are altered, tidal tails are drawn out, gas is compressed, shocked, and redirected. Star formation can surge in some regions, disks are distorted, thickened, and eventually transformed. What collides is not star against star. What collides is order against order. That is a much stranger thing to imagine. The graceful rotating architecture of one spiral galaxy, interpenetrating the gravitational architecture of another, each pulling on the other's stars, gas, and dark matter halo, each eroding the clean autonomy of the other's prior identity. Over time, the two systems do not simply hit and remain distinct. They exchange energy, transfer angular momentum, draw out vast tidal structures, and settle toward a new combined configuration. The result is not annihilation, it is synthesis through disturbance. A merger is what happens when two histories lose the right to remain separate. That phrase belongs here because it exposes the continuity between the Milky Way's current behavior and its larger fate. The galaxy already devours dwarfs. It already absorbs streams. It already reworks acquired matter into itself. The Andromeda encounter is the same logic at a higher scale. The difference is not kind. It is consequence. For once, the Milky Way will not merely be the host extending its influence over something much smaller. It will be one participant in a mutual restructuring between giants, and that mutuality makes the future feel colder and more beautiful. Simulations of the encounter suggest that the Milky Way and Andromeda will pass through each other, loop, draw apart, fall back, and eventually merge into a larger remnant galaxy often informally called Milkomeda. The familiar disks will not survive unchanged. Spiral structure will be disrupted and then lost. The night sky, if anything like human observers, remains somewhere inside the system, would not resemble the stable band of the modern Milky Way. Andromeda itself would grow from a distant smear into a colossal occupying presence across the sky long before the deepest phases of merger began. The heavens would cease to look like a background and become a mechanical event. And even that sentence fails to carry the full weight of it, because by the time the visual drama became overwhelming, the real process would have already been running for ages. Tidal effects would be reshaping outer regions. Gas dynamics would be shifting. Halo interactions would be exchanging influence long before the eye could narrate the scene as collision. Once again, the universe would begin the true event before human intuition recognized where the event had started. This is one of the deepest recurring lessons in cosmology. Reality happens in advance of our metaphors. We keep wanting moments. The universe keeps giving us gradients. And that is why the approach of Andromeda matters now. Not merely later. It forces us to treat the Milky Way not as a completed local system, but as one participant in a broader gravitational architecture still evolving. The local group itself is a process. The future remnant is not an unrelated sequel. It is the delayed expression of motions already written into the present. The Milky Way is not waiting for history to happen to it. It is history in progress. This also reframes every smaller act of feeding we have already traced. The Sagittarius dwarf, the stellar halo, the gaseous streams, the corona, the central black hole waiting under contingent supply. None of these are disconnected curiosities. They are all local expressions of the same underlying principle. Galaxies are not static containers of matter. They are dynamic systems that accumulate, restructure, recycle, and sometimes merge into larger systems still. What Andromeda reveals is not a new theme. It reveals the full scale of the existing one. And once you see that, something subtle changes in the emotional meaning of the word home. The Milky Way feels intimate to us, partly because it is the structure that contains our sun. But, galactically speaking, intimacy is not stability. We happen to live inside one phase of a larger process. The galaxy that made our existence possible is itself temporary in form. Its spiral arms are temporary. Its present disk is temporary. Its distinction from Andromeda is temporary. The night sky, as human beings have inherited it, is not the face of a permanent order. It is the local appearance of a transitional era. That does not make it less precious. It makes it harder to sentimentalize. Because sentimentality relies on the fantasy that beauty and duration naturally coincide, they do not. Some of the most beautiful structures in the universe are temporary configurations passing through lawful instability. Spiral galaxies may be among the finest examples. Their elegance is real. Their longevity is immense on human scales. But cosmologically, they are phases, not final forms. The Milky Way's beauty is not the beauty of a thing exempt from transformation. It is the beauty of a thing caught between earlier assembly and later merger, glowing during one interval of structural grace. A spiral galaxy is a solved problem only for a moment. Andromeda makes that impossible to ignore, because one day the Milky Way's current architecture will no longer exist. Its stars will still exist in large part. Its matter will still participate in a larger bound system. But the identity we now project onto the galaxy, its shape, its sky, its clean distinction from its nearest large neighbor, will not survive untouched. The future of the Milky Way is not indefinite continuation. It is integration. The galaxy will become part of something it is not yet. That line could easily collapse into cheap profundity if mishandled, so it has to stay physical. The merger will be driven by gravity, dynamical friction, tidal exchange, gas dynamics, and long-term orbital evolution. No philosophy needs to be imported to make it meaningful. The meaning is already in the mechanics. The same universe that allowed the Milky Way to assemble from smaller pieces also places it on a path toward being reassembled at a higher level. Growth is not a phase the galaxy will someday complete. Growth remains the rule all the way up to the point where available partners, gas reservoirs, and cosmological expansion begin to change what kinds of growth remain possible. And that naturally sharpens the question underneath all of this. If the Milky Way grows by capture, by inflow, by conversion, by merger, Then what does growth even mean at galactic scale? Human language tends to flatter growth: more mass, more stars, larger structure, extended influence. But from the galaxy's point of view, growth is not gentle accumulation. It is reorganization through disruption. It is identity surviving by incorporating what once was other. It is continuity purchased through repeated endings. The Milky Way does not grow the way a tree grows. It grows the way a storm system grows, by drawing in matter, redistributing energy, and changing character as it expands. And once that truth is clear, the next realization becomes unavoidable. The galaxy did not merely make room for life. It made life out of ruin. That is not metaphor in the decorative sense. It is chemistry, history, and consequence compressed into one sentence. Everything we have traced so far, the swallowing of dwarf galaxies, the stripping of stars into streams, the circulation of gas through the halo, the slow transfer of matter from invisible reservoirs into luminous structure, the future merger with Andromeda already underway in the deep grammar of gravity. All of it can still feel remote until the story closes one final distance. The distance between the galaxy and the body. Because once you ask what galactic growth actually produces, the answer is not only more stars, more mass, more debris, more structure. It is also us, not as the intended result of any cosmic purpose, not as the moral center of the process, but as one of its lawful consequences. The Milky Way did not simply create a place where life could appear. It created the raw materials of life by passing matter through repeated eras of concentration, ignition, death, dispersal, and reuse. We are downstream of stellar violence. That line should be felt physically, because it is physical. The carbon that forms the backbone of organic chemistry was forged inside stars. The oxygen you breathe, the calcium in bone, the iron in blood, the silicon in rock, none of these elements were simply present in useful abundance from the beginning. Hydrogen and helium dominated early cosmic matter. Heavier elements had to be manufactured in stellar interiors and in catastrophic deaths powerful enough to distribute them into surrounding space. The universe had to spend a long time not being ready for bodies like ours. Complexity had to be earned by burning. And that earning did not happen once. It happened generation after generation. Early stars formed from relatively unenriched material. They lived, burned, and died. Their deaths returned heavier elements to the gas around them. Later stars formed from that enriched material, making planetary systems more plausible, chemistry more varied, structure more interesting. Some stars ended quietly, shedding outer layers. Others died in supernovae violent enough to scatter newly forged matter across interstellar space. Neutron star mergers likely contributed some of the heaviest elements of all. Over immense time, the galaxy became chemically richer, not by avoiding death, but by requiring it. A sterile galaxy can shine. A fertile galaxy must remember how to explode. That is one of the hardest truths in the whole descent, because it transforms the emotional meaning of beauty. Star formation regions, luminous nebulae, glittering spiral arms. These are not just signs of abundance. They are signs of a system that has repeatedly processed matter through states severe enough to create the ingredients of later life. The Milky Way is not beautiful, despite its violence. Much of its beauty and possibility arise because the violence was there. And once again, the halo changes tone under that realization. The shredded remnants of absorbed galaxies are not only evidence of appetite, they are also part of the material history from which later generations of stars and planets can be assembled. Captured gas can become new structure. Enriched debris can enter the wider circulation. Material stripped from one gravitational home can contribute, eventually and indirectly, to another. The galaxy feeds on endings to produce beginnings. This is where growth becomes a dangerous word if used lazily, because the human instinct is to hear growth and imagine a smooth upward curve, increasing fullness, increasing completion, increasing security. But galactic growth is not security, it is throughput. It is the transfer of matter across states, often destructive states, in ways that enlarge what the galaxy can become. More stars, yes. More structure, yes. but also more ash, more debris, more heating, more scattering, more old forms broken so that later forms can emerge. The Milky Way is constructive in the most unsentimental way possible. It does not protect complexity first and build around it. It makes complexity by repeatedly destroying simpler arrangements and redistributing their material. A gas cloud collapses and loses its diffuse freedom to become a star. A star dies and loses its coherence to seed later chemistry. A dwarf galaxy falls in and loses its identity to enrich the larger whole. Even the future merger with Andromeda, catastrophic at the level of galactic form, will not erase matter from the universe. It will reorganize it. Disks will be lost. New long-term structures will emerge. Existing order will be broken into another order. The universe is not sentimental about continuity of form. It is interested in continuity of transformation. That distinction matters because it cuts directly against the oldest illusion humans bring to the sky, that what matters most is what stays recognizably itself. But the Milky Way teaches a harsher lesson. At cosmic scale, what matters is often not what remains unchanged, but what continues to participate in larger chains of becoming. Matter survives. Identity often does not. Structure persists by changing form. What we call a galaxy is not a permanent self. It is an evolving regime under which certain kinds of transformation remain possible. And life appears inside one especially narrow interval of that regime. Too little chemical enrichment, and rocky planets and complex chemistry struggle to arise. Too much violent activity nearby, and long-term biological stability becomes difficult. Too little star formation over time, and there are fewer opportunities for planetary systems to emerge. Too much environmental disruption, and local habitability becomes fragile. The fact that a world like Earth could form in a galaxy like the Milky Way is not a sign that the galaxy is peaceful. It is a sign that its violence had a survivable structure. Home is what happened when the damage became useful. That line is severe, but it is also disciplined by the science. The sun formed from gas already enriched by prior generations of stars. The solar system condensed from material carrying the chemical legacy of earlier stellar evolution. Earth's rocks, oceans, atmosphere, and eventual biochemistry all belong to a universe that had already been working on matter for billions of years. We do not stand outside galactic history and observe it from safety. We are one expression of what galactic history eventually made possible. The Milky Way is in us as much as around us, and that should alter the emotional balance of everything we have seen. The galaxy's appetite is no longer merely external. Its past mergers, stellar deaths, gas cycles, and long chemistry are not just things that happened out there in an indifferent spectacle. They are part of the hidden prehistory of our own existence. The iron and blood is not merely from stars in some vague educational slogan. It comes from a galaxy that repeatedly allowed matter to enter stars, leave stars, move through gas, survive collapse, and become part of later planetary bodies. The carbon in a cell is not simply stardust. It is recycled galactic matter that passed through fires older than the sun. A body is a local archive of cosmological processing. That statement could easily sound grandiose if the story had not earned it step by step, but now it has. We have already followed matter from hidden gravitational scaffolds into galactic assembly, from assembly into accretion, from accretion into halo memory, from halo memory into tidal stripping, from stripping into gas cycling, from gas cycling into the conditions for star formation, from star formation into the longer question of what stars eventually return to the galaxy. The body is not a poetic leap away from that chain. It is the nearest consequence of it. And yet there is something unsettling in that nearness. Because if life depends on a history like this, then comfort was never the deep condition of our existence. We came from lawful instability, from repeated thresholds crossed by matter under pressure, from a galaxy that survives by never being fully closed, fully finished, fully still. The human desire for a stable universe, a clean stage on which life briefly acts, is not reflected in the Milky Way's actual structure. The stage itself is moving. The scenery is consuming and being consumed. The chemistry that made the actors possible came from ancient episodes of combustion and ruin. The universe did not calm down enough to let us happen. It stayed active in exactly the right ways. This does not make life meaningless. It gives life a harder kind of dignity. We are not exceptions to cosmic process. We are made of it. The Milky Way does not contain an island of biology floating apart from its deeper physics. Biology is one more phase in what enough processed matter can become under the right conditions. The same galaxy that tears dwarf systems into streams also grows molecular clouds, forges heavy elements through generations of stars, and permits planets to condense from enriched debris. Creation and destruction were never separate departments. They were one circulation. And once that is clear, the future of the galaxy starts to feel different as well. The coming merger with Andromeda is no longer simply a distant catastrophe to contemplate from safety. It becomes one more turn in the same governing principle. The forms will change. The bright familiar band of the Milky Way will not remain what it is forever, but the deeper logic, concentration, restructuring, conversion, delayed consequence will continue. New stars may still form for a time in merger-driven episodes. Gas will be redistributed. Histories will be folded together. The identity we call the Milky Way will loosen, but matter will keep moving through larger structures and new conditions. Growth will continue by ending forms that once felt final. Or which means the most honest way to look at the galaxy is no longer as a place, and not even only as a process, but as a process that produces temporary places, intervals of relative order, inside larger currents of transformation. The Milky Way was such an interval for the Sun. The solar system was such an interval for Earth. Earth was such an interval for life. Stability exists, but not as a fundamental state. It exists as a local achievement inside a universe that does not stop moving matter through deeper laws. The galaxy gave us a temporary home by refusing to be permanently still. And that is why the final descent has to move beyond appetite altogether. Because Devours is true, but it is not yet complete. The Milky Way does consume. It strips, it captures, it recycles, but the deepest reality is not hunger alone. It is unfinished transformation. The river of light over our heads is not a monument to what the galaxy already became. It is a cross-section through what it is still becoming. That is the line everything has been leaning toward, because it corrects the final illusion left standing. We began with the Milky Way as an image, a river of light, a familiar scar across the night, something apparently finished, or finished enough that the mind could treat it as scenery. But scenery is what reality becomes when motion is stretched beyond the scale of feeling. The Milky Way never was scenery. It only became readable that way to creatures whose lives are too short to register what the galaxy is doing in its own time. We inherited a still frame and mistook it for a stable thing. We saw continuity and called it permanence. We saw light and assumed it marked the whole structure. We saw beauty and quietly attached to it the comforting idea of completion. Now none of those assumptions survives intact. The galaxy is not held together by what shines. It did not grow by peaceful accumulation. Its halo is not empty background. Its outskirts are full of memory. Its future is not self-contained. Its stars are not beginnings, but visible consequences. Its chemistry was paid for by older destruction. Its apparent calm is a timing effect. And perhaps most unsettling of all, its identity is real only in the temporary way that patterns are real inside long processes. Real enough to matter, real enough to shape worlds, real enough to give rise to bodies, histories, and observers. But not final, not exempt, not beyond reorganization. A galaxy is a temporary coherence inside larger laws. That is not a reduction of wonder. It is the mature form of wonder. Because the childish version of awe wants the universe to be made of enormous things. Big stars, big galaxies, big black holes, vast distances. All of that can impress, but it still leaves the deeper picture untouched. The mature form arrives later, when size stops being the main revelation and structure takes over. When the true shock is no longer that the Milky Way is large, but that it is lawful in ways human intuition does not naturally forgive. It looks still and is not still. It looks complete and is not complete. It looks luminous and is mostly governed by the unseen. It looks like a place and is really a history in motion. That is a harsher beauty. And once you accept it, even the word devours starts to deepen rather than collapse. At first, the word seems almost too dramatic, as if we are imposing biological hunger onto a physical system that knows nothing of desire. Then, the evidence accumulates. Dwarf galaxies are stripped apart. Their stars are wrapped into streams. Gas is captured, heated, mixed, and eventually turned into future light. The halo preserves the remains. The disk uses the inheritance. The center waits with its own local form of appetite. Andromeda approaches. The larger future is already written into the present. So yes, the Milky Way devours. But it devours the way gravity always devours, by making other structures less able to remain themselves. That is the key. Not appetite as intention, but appetite as consequence. A deep enough gravitational system changes the fate of what enters it. It strips, delays, traps, reorganizes, and keeps. It turns separate histories into part of a larger one. It does not need desire to behave with something almost indistinguishable from patience. And because the universe is old, patience is enough. Gravity eats by outlasting resistance. That line belongs here because it reframes the whole emotional logic of the galaxy. We keep expecting violence to announce itself through noise, heat, rupture, spectacle, and sometimes it does. But some of the deepest violence in nature is cold, extended, and lawful. A small galaxy loses itself over repeated orbits. A stream stretches until identity becomes geometry. Gas waits in the halo for ages before becoming star-forming fuel. A black hole remains dim for long intervals, then brightens when conditions shift. Two giant spirals approach one another for billions of years before the sky would ever describe it as collision. Reality is not built to satisfy the human taste for scenes. It is built to continue. And that continuity is exactly why the Milky Way matters philosophically, not just scientifically, because the galaxy exposes a mismatch between how reality feels and how it works. Human beings trust local appearances. We orient by surfaces. We build intuition from the visible world at bodily scale. At that scale, solid things look solid. Empty regions look empty. Stable patterns feel finished. Motion is what happens when something changes fast enough to register. The Milky Way quietly breaks all of those habits. Its visible matter is not its decisive mass. Its empty surroundings are full of gas, influence, and future. Its stability is active maintenance, not final rest. Its growth is not linear addition, but recursive transformation. Its present is thick with delayed consequences from events older than the sun. And perhaps that is why a galaxy can feel more destabilizing than a black hole once you really see it. A black hole is obviously strange. It advertises its severity. The Milky Way is more subtle. It hides its strangeness behind familiarity. We have always lived inside it. We know its name. We see it in photographs. We draw it cleanly in diagrams. It enters culture as backdrop, as home, as celestial geography. Then the science removes the comfort one layer at a time. Home is not fixed. The background is an archive of consumed worlds. The light is a late symptom. The future is already inbound. And the body asking these questions is made from the same chain of violence and reuse. There is no untouched position from which to watch. That is what gives the whole story its final pressure. We are not outside the Milky Way evaluating it as an object. We are inside one interval of its becoming, using matter it already processed, under skies shaped by a temporary phase of its structure, asking questions made possible by stars that died before the sun was born. The galaxy is not just what we observe. It is one of the conditions that made observing creatures possible at all, which means the last temptation has to be resisted. The temptation to turn this into consolation. It would be easy to say that because we are made of stellar remnants, because the galaxy's violence eventually permitted life, because structure emerges from destruction. The universe is therefore somehow kind beneath its harshness. But the science does not promise that. It promises only lawfulness. A lawful universe can produce beauty, fertility, and consciousness without ever becoming emotionally comforting. The Milky Way is elegant. It is not merciful. It is creative. It is not gentle. It produces worlds, but only by moving matter through states that do not care what local forms are lost along the way. The laws of the universe are lawful. They are not psychologically tailored. That may be the most adult realization in the entire descent. Because once you release the demand for comfort, something cleaner appears in its place. Not despair, not nihilism, something closer to cold intimacy. The recognition that reality is not arranged for us, and yet we can belong to it more deeply once we stop asking it to resemble our emotional preferences. The Milky Way is not a sanctuary because it stays still. It is our cosmic home only in the harder sense, the sense that we arose within its lawful turbulence, and our understanding becomes truer the less we soften what the turbulence is. Truth does not always soothe. Sometimes it enlarges belonging by removing innocence. And so, the night sky changes one last time. The bright band above us is no longer just the visible plane of our galaxy. It is no longer a decorative ribbon, no longer merely a star field, no longer simply evidence of scale. It becomes a present tense slice through a structure still feeding, still sorting matter, still turning gas into stars, still carrying the remains of smaller worlds in its halo, still moving toward a future merger that will erase the current shape, still governed by mass we cannot see, still converting ancient death into later possibility. The Milky Way is not what the galaxy was. It is what the galaxy is doing. That sentence is the real answer to the title, because it removes the last trace of spectacle language and leaves the mechanism standing. The Milky Way devours galaxies every single day. Sounds at first like a dramatic claim about cosmic violence. By the end, it means something larger and more precise. The Milky Way is a gravitational system that continuously incorporates external matter, strips smaller structures, circulates hidden fuel, reorganizes inherited debris, and persists by remaining unfinished. Devouring is one visible expression of a deeper fact. Home is an active process of assimilation. And now the opening image returns, but it does not mean what it meant before. Look up again on that same clear night. The pale river is still there, the same soft architecture of dust and stars, the same band that ancient people saw without knowing they were inside it, the same apparent stillness that tempted generations into thinking the sky was a fixed design stretched above a temporary world. But now the stillness has been broken from within. Some of that light comes from stars born of recycled matter. Some of the darkness is dust that will participate in future stars. Some of the halo beyond sight contains the remains of absorbed galaxies. Some of the gas above the disk is part of a future not yet luminous. Some of the structure holding all of it together cannot be seen at all. And somewhere within that larger system, another small galaxy is already less separate than it used to be. The sky did not become stranger when we discovered more about it. It was always this strange, knowledge just removed the disguise. So, the final realization is not that the Milky Way is violent, though it is, not only that it is unfinished, though it is, not only that it made life out of ancient destruction, though it did. It is that reality's deepest structures are often least intuitive, where they feel most familiar. The thing we call home is not a resting place in the universe. It is one brief, luminous phase of an unfinished event. And if that sounds abstract, it only means the mind is trying one last time to retreat into distance. So, bring it back down. Bring it back to the simplest possible act, standing under the night sky and looking up long enough for the old interpretation to fail. Not because the stars change while you watch, not because some visible catastrophe unfolds above you, but because once the deeper architecture is known, even stillness becomes difficult to trust in the same way. The Milky Way remains beautiful. That has not been taken away. If anything, the beauty becomes more exact. But it is no longer the beauty of a finished masterpiece hung in darkness. It is the beauty of dynamic order, of matter held in forms that persist for a while, not forever, of structures that survive by changing, of light emerging from histories that were invisible for most of their duration. A mature view of the galaxy does not reduce wonder. It removes innocence from wonder. That distinction is important because much of popular science quietly offers a bargain the real universe never signed. It tells us that deeper understanding will make reality feel smoother, more unified, more emotionally legible. Sometimes it does the opposite. Sometimes deeper understanding enlarges the fracture. You do not come away feeling that the universe has become more comfortable. You come away feeling that comfort was an early simplification, useful, local, human, and false. The Milky Way is one of the clearest examples of that reversal. At first it feels obvious. A galaxy is a vast collection of stars. Then motion reveals the hidden mass. Then the halo reveals earlier mergers. Then the streams reveal torn galaxies. Then gas cycling reveals invisible supply. Then star formation stops looking like spontaneous beauty and starts looking like delayed consequence. Then the central black hole adds a waiting severity. Then Andromeda enters as a future already underway. And by the time all of those layers are in place, the original image of the Milky Way has not merely become richer. It has become less psychologically forgiving. The galaxy is lawful, yes. Elegant, yes. Magnificent, yes. But none of those words restore the old simplicity. Because the old simplicity depended on boundaries that do not really exist. A neat line between visible and real. A neat line between growth and destruction. A neat line between home and process. A neat line between present structure and past violence. A neat line between the body and the cosmos that made it. One by one, those lines dissolve. And what replaces them is not chaos, it is continuity. That may be the hardest thing to absorb. The Milky Way does not become more astonishing because it is secretly irrational. It becomes more astonishing because its hidden logic is so coherent. The same gravitational principles that hold outer stars in their orbits also trap satellites. The same thermodynamic realities that make gas hard to cool also govern the reservoirs from which future stars can emerge. The same history that shreds dwarf galaxies also enriches the larger structure with matter that can later become light, planets, and chemistry. The same future merger that will erase the current Milky Way's familiar form is an extension of the same assembly logic that built it in the first place. The galaxy is not contradictory. It is consistent at a level that human intuition was never built to feel. And that is why the script cannot end on spectacle. Spectacle would make the whole story smaller. It would reduce the Milky Way to a scene, a giant thing doing dramatic things in a giant universe. But the real effect is more intimate than spectacle and more destabilizing than awe. It is the recognition that the hidden structure of the galaxy is also a hidden structure in our own assumptions. We thought stillness meant stability. We thought light meant substance. We thought beauty meant finished form. We thought home meant enclosure. We thought growth meant addition. The Milky Way quietly dismantles all five. Stillness can be only slowness. Light can be only the thin visible layer of something deeper. Beauty can belong to temporary structures in active transformation. Home can be made of permeability and exchange. Growth can be reorganization through loss. Those are not merely astronomical facts. They are corrections to the way the mind tries to build reality out of immediate appearances. And perhaps that is the real reason galaxies feel so philosophically powerful when they are understood properly. Not because they answer our largest questions with comforting grandeur, but because they expose how provincial our intuitions are. Human perception evolved to survive among solid objects, local weather, brief timescales, and visible causes. It did not evolve to understand diffuse plasmas spread across hundreds of thousands of light years, or the orbital digestion of dwarf galaxies, or the idea that a luminous spiral can be mostly governed by unseen mass, or that a system can spend billions of years making itself out of what it destroys. A galaxy is almost designed to embarrass intuition, and there is something healthy in that embarrassment. Because once intuition is no longer treated as the final court of what counts as real, a different form of contact becomes possible, more disciplined, less sentimental, less eager to project human categories outward and then mistake the projection for understanding. You stop asking the Milky Way to behave like a monument or a machine or a city or a home in the ordinary emotional sense. You let it be what it is, a gravitational history still underway, with visible and invisible components, with memory in its halo, with potential in its gas, with patience in its violence, and with a future that has already begun altering the meaning of its present. That is a colder intimacy. But intimacy all the same. The universe often becomes more relatable in the wrong way when we narrate it carelessly. We give it moods, motives, and familiar emotional postures. We make it wrathful, or maternal, or grandly benevolent, or theatrically hostile. The Milky Way deserves better than that. It deserves language disciplined enough to preserve its alienness without turning that alienness into empty mystique. Because the truth is already enough. A galaxy can assemble itself from hidden structure, consume smaller galaxies without ever roaring, store future stars in invisible reservoirs, carry the bones of old mergers in its halo, build the chemistry of life from prior stellar death, move toward a future integration with another giant spiral, and look, all the while, like a quiet band of light crossing the sky. No embellishment improves that. If anything, embellishment weakens it by trying to make it easier to feel. The better response is to let the feeling arrive on the far side of precision, to let the force of the Milky Way come not from inflated language, but from the sustained removal of wrong assumptions. That is how reality becomes haunting, not because someone told us it was haunting, because the mechanism honestly followed, left us with no simpler place to stand. The Milky Way is haunting because it is exact, and that exactness changes what it means to belong to it. Belonging no longer means residence inside a stable container. It means participation in a process large enough to precede us, exceed us, and continue after every familiar form has changed. The sun belongs to the Milky Way because it formed from its chemically enriched matter. Earth belongs to it because Earth condensed inside one local branch of the galaxy's long thermodynamic history. We belong because our bodies are made from what the galaxy had already processed. Even our questions belong, in a sense, to the same chain. Because a galaxy capable of forging heavy elements, long-lived stars, rocky planets, and stable intervals of habitability is also a galaxy capable of producing minds that can turn around and ask what kind of structure they inhabit. The Milky Way did not merely surround consciousness. It participated in making consciousness possible. That realization is easy to cheapen and hard to earn. Earned properly, it does not elevate us above the galaxy. It does the opposite. It places us more deeply inside it. Our significance is not that we stand apart from cosmic process and observe it from some clean philosophical distance. Our significance, such as it is, lies in being one of the things that process eventually made. Thought is one more local event in galactic history. Matter learned to ask what matter had become. There is a severe tenderness in that sentence, but only because the science makes it legitimate. The same galaxy that strips satellites and recycles gas can also, under the right local conditions, produce worlds where atoms organize into cells, cells into nervous systems into awareness, and awareness into inquiry. None of that softens the violence. It only reveals a wider continuity than violence alone can capture, which is why the title now lands differently than it would have at the beginning. The Milky Way devours galaxies every single day. At first, it sounds like a claim about danger, a giant object doing something brutal somewhere far away. By now, that reading is too small. The Milky Way does devour galaxies, yes, but the point is not simply that it destroys. The point is that destruction is one instrument inside a larger cosmic metabolism. The galaxy captures, strips, circulates, cools, reignites, enriches, and reorganizes. Its violence is real, its fertility is real, its future transformations are real, its visible stillness is not. The title was never only about devouring. It was about what kind of thing a galaxy has to be for devouring to be ordinary. And the answer is now unavoidable. A galaxy has to be a process before it is a place, a history before it is an image, a deep gravitational regime before it is a river of light. an unfinished event before it is a home. That is the mature form of the opening. And once that lands, even silence feels different. Go back, then, to the sky one last time, not for a new fact, but for a new way of seeing the same fact. The band overhead has not changed. The dust lanes are still there. The stars are still there. The apparent calm is still there. But now the calm is underwritten by hidden mass. The stars are outcomes of older infall. The halo beyond sight is full of remnants. The gas above the disk is carrying futures not yet luminous. The center waits in conditional hunger, and the entire system is moving, even now, toward a later form in which the galaxy we call the Milky Way will no longer remain itself in quite the same way. The sky is no less beautiful for this. It is more difficult to look at innocently, and that difficulty is the gift. Because the final effect of understanding is not that the universe becomes smaller, safer, or more familiar, it is that familiarity itself breaks open. The most familiar large structure in our cosmic life turns out not to be a stable backdrop, but a vast, unfinished act of assimilation and transformation, one whose earlier violence made our existence possible, and whose future will erase the temporary shape we have mistaken for permanence. The Milky Way is not the memory of a galaxy. It is the present tense of one. And the present tense is always harder to live with than the past. The past can be arranged, named, archived, turned into cause. Once an event is safely behind us, the mind begins to convert it into explanation. But the present is more difficult because it does not allow that comfort. It remains unfinished. It has not yet revealed which of its hidden motions will later matter most. It forces us to stand inside process rather than outside outcome. That is the real disturbance the Milky Way creates once you understand it properly. Not just that it has consumed, not just that it will merge, not just that it forged the chemistry of life through repeated stellar death, but that all of these are not isolated facts. They are phases of one ongoing grammar of matter, and we happen to exist in the middle of a sentence whose end we will never see. A galaxy is not only larger than us, it is less complete than we wanted it to be. That sounds paradoxical at first. Bigger things are supposed to feel more finished. Mountains feel finished, oceans feel finished, continents feel finished. Even when we know they change, they retain the emotional authority of completed forms. Their timescales are slow enough and their structures coherent enough that the mind allows them the dignity of seeming settled. The Milky Way refuses that dignity. It is too large to watch directly and too active to deserve the illusion of finality, which means it occupies a peculiar category in human thought, something vast enough to feel architectural, yet dynamic enough that architecture is the wrong emotional model. That is why the galaxy can feel so strangely intimate once its true nature comes into view, not because it becomes smaller, but because its instability begins to rhyme with something we already know at other scales. Everything real is less finished than it looks. That is not a mystical statement, it is a structural one. Stars are active furnaces while appearing as points of steady light. Planets are dynamic interiors under apparently solid surfaces. Living bodies are continuous metabolic exchange under the illusion of fixed identity. Galaxies are long negotiations of gravity, gas, heat, memory, and capture under the illusion of celestial stillness. The Milky Way is simply the largest familiar thing in our experience that makes this lesson impossible to avoid. And once that lesson is absorbed, another emotional reversal happens. The galaxy stops being merely an object of awe and becomes a critique of human perception. That may sound severe, but it is deserved. We trust the visible because, at human scale, the visible is often enough. We trust edges because bodily life depends on knowing where one thing ends and another begins. We trust immediate causation because our survival depends on recognizing nearby change quickly. We trust stillness because things that remain unchanged across our brief timescales are usually stable enough for practical purposes. The Milky Way quietly invalidates all four habits. Its decisive mass is not visible. Its edges are gradients of influence, not lines. Its causes are spread across deep time and distributed structure. Its stillness is a failure of our senses, not a property of the thing itself. This is not just astronomy teaching us new facts. It is astronomy revealing where ordinary intuition stops being a reliable guide to reality. And that is why science, at its highest level, can feel less like information and more like moral pressure. Not moral in the narrow sense of ethics, but in the larger sense of demanding intellectual honesty. The Milky Way does not care what kinds of explanations feel emotionally manageable to us. It does not simplify itself to preserve our categories. It asks us to accept that visible calm can hide active violence, that beauty can be a temporary phase of ongoing reorganization, that home can be a porous system built from acquisition and loss, and that our own existence can depend on processes that are lawful without being kind. There is something cleansing in that refusal, because once the universe is no longer forced to resemble our emotional preferences, its real form begins to emerge with greater precision. The Milky Way becomes neither a sentimental sanctuary nor a monstrous threat. It becomes what it is, a vast gravitational regime in which matter is sorted, recycled, concentrated, disrupted, and sometimes made luminous. Its grandeur no longer depends on personification. Its severity no longer needs amplification. The mechanism is enough. The mechanism is always enough when it is seen clearly. That is worth dwelling on, because so much weak science storytelling fails exactly here. It tries to compensate for a lack of structural clarity with verbal inflation. It tells us things are terrifying, beautiful, mind-blowing, humbling, incomprehensible. But the strongest realities do not need to be announced. They gather force as each wrong simplification is removed. By the time you arrive at the end, the feeling is not manufactured emotion. It is pressure released from the truth itself. The Milky Way earns that pressure. It earns it by being harder than the image suggests, harder in the sense of less reducible, less obedient to the surface, less willing to become a single thing for the sake of understanding. It is a halo of hidden mass, a disk of circulating fuel, a graveyard of mergers, a nursery of stars, a reservoir of delayed possibility, a core with a dormant black hole, a participant in a future giant merger, a source of the chemistry that built bodies, an unfinished event presenting itself as scenery. No single metaphor survives all of that. And perhaps that is the final sign you are approaching reality instead of merely language. Metaphors help, but they begin to break under the weight of the structure they were meant to clarify. Weather helps, cities help, rivers help, appetite helps, but none of them are sufficient. A galaxy is not like one familiar thing. It is a regime under which many familiar patterns partially apply and then fail. That failure is not a weakness of understanding. It is one of the marks of understanding, because reality at this scale does not become more truthful when it becomes simpler than it is. The real advance is learning how to keep multiple partial truths in view without flattening them into a comforting lie. The Milky Way is beautiful and violent, stable in some respects, unfinished in others, a source of life, and a structure built through repeated loss. Familiar to the eye, alien to the deeper mind, home, but only in the hard sense that home can itself be a process of assimilation. That is what mature clarity sounds like. Not one final slogan, but a sharper tolerance for complexity without vagueness. And complexity here does not mean confusion. The pattern is clear, gravity concentrates, matter falls, some of it cools, some of it forms stars. Stars enrich later matter, smaller systems are captured and stripped, gas cycles through visible and invisible phases. Larger mergers await, identity persists for a while, then loosens. The galaxy remains itself by continuing not to be finished. The Milky Way is coherent because it is dynamic, not despite it. That is a line worth carrying forward because it does not apply only to galaxies. Once seen here, the lesson begins to generalize. The world does not become real by reaching stillness. Many of the most enduring structures in nature persist by throughput, by the continual movement of matter and energy through forms stable enough to last, unstable enough to remain alive. Stars, climates, oceans, ecosystems, bodies, and galaxies all share this more difficult kind of coherence. They are not fixed, they are maintained. We misunderstood permanence because we mistook persistence for stillness. The Milky Way corrects that error at overwhelming scale. And in doing so, it also changes how we understand time. Not abstractly, viscerally. Human time is all thresholds and episodes: birth, death, decision, event. Galactic time is different. It is layered, overlapping, recursive. A stream in the halo is an ancient merger still legible in the present. Gas entering the corona may become part of stars millions of years later. A black hole can remain quiet for long intervals, then flare when supply changes. Andromeda's approach is both present fact and future transformation. The past is not gone in the simple way human memory imagines. It persists as structure. The future is not absent in the simple way ordinary expectation imagines. It already exists as trajectory. In a galaxy, time is not only what has happened, it is what remains physically active in the present. That may be the hardest intellectual movement of all, because it asks us to stop treating time as a sequence of vanished moments and start treating it as a set of layered consequences still inhabiting one another. The Milky Way's halo is the past still orbiting. Its star-forming regions are prior infall becoming visible. Its central black hole is latent future brightness waiting on supply. Its chemistry is dead stars inside living bodies. Its coming merger is present motion not yet recognized as present by instinct. A galaxy is what time looks like when time hardens into structure. And once that settles in, the night sky cannot quite return to being decorative again. Even if you try, the knowledge remains like a pressure behind the eyes. That band of light is not merely there. It is carrying hidden mass, remembered mergers, circulating gas, ongoing star birth, dormant severity at the center, and an eventual loss of its current form already encoded in motion. It is not only a thing to be seen, it is an argument against easy appearances. The sky is a lesson in how much reality can hide inside one image. That is where the next movement has to go, not into new mechanism, but into the final consequence of accepting all of this without retreating into either despair or sentiment. Because once innocence is gone, two temptations remain: to make reality colder than it is, or to make it warmer than it is. Both are evasions. To make reality colder than it is would be to turn the Milky Way into nothing but machinery, a blind engine of gravity and thermodynamics in which beauty is dismissed as projection and life becomes an accidental side effect, too trivial to mention, except as chemistry. That kind of narration flatters itself as hard-minded, but it fails in its own way. It notices mechanism and then refuses consequence. It forgets that lawful processes can produce genuine splendor, genuine fragility, and genuine forms of meaning without becoming designed or benevolent. But to make reality warmer than it is would be the opposite error. To take the fact that life emerged from galactic history and quietly upgrade the galaxy into a nurturing presence. To treat cosmic fertility as proof of cosmic kindness. To mistake lawful generativity for care. That temptation is gentler, more attractive, and no less false. The Milky Way allows neither comfort. And that is precisely why it can leave behind something more durable than comfort. What remains, once both temptations are stripped away, is a kind of lucid belonging, not the belonging of safety, not the belonging of being specially intended, something cleaner, the belonging of participation in a structure that did not need to resemble us in order to produce us. The recognition that our existence is not exempt from the galaxy's processes but continuous with them, that every instinct we have for stillness, enclosure, permanence, and finished form was built too locally to read the larger truth. We belong, but not as favorites. We belong as consequences. That sentence should not be heard as diminishment. It is a reduction only if dignity depends on being central. But the deeper dignity here is the opposite. It is the dignity of being real inside reality, not above it, made from the same matter, subject to the same laws, emerging from the same long chain of concentration, ignition, dispersal, and reuse. We are not outside the Milky Way judging it from some neutral philosophical ledge. We are one late local articulation of its history, one way the galaxy briefly became aware enough to ask what kind of thing it is. And then, inevitably, the question changes shape one final time. Not what is the Milky Way? We have answered that as far as one script can, A hidden mass structure, a star-forming disk, a halo of debris and memory, a system of inflow and recycling, a host that strips smaller galaxies, a participant in a future giant merger, an unfinished gravitational regime. The final question is harder. What does it do to a mind to know that this is what home really is? At first, perhaps very little. Information alone rarely changes perception in a durable way. One can learn about tidal streams, dark matter halos, gas accretion, stellar nucleosynthesis, even the Andromeda merger, and still carry on feeling the Milky Way as a familiar astronomical object. Facts can sit on the surface of the mind for years without disturbing the deeper architecture underneath. But once the structure locks together, something subtler happens. The galaxy stops being a topic and becomes a correction. It corrects the reflex that equates visibility with importance. It corrects the reflex that equates stability with stillness. It corrects the reflex that treats boundaries as cleaner than they are. It corrects the reflex that imagines creation and destruction as opposites. It corrects the reflex that mistakes temporary form for final identity. And those are not small corrections. They propagate. Once they are learned at galactic scale, they begin to echo elsewhere. You start to see that many of the deepest structures in reality do not present themselves honestly to immediate intuition. That visible order is often the late expression of hidden conditions. That a thing can persist by changing form. That what appears complete can be in transit. That what appears empty can be full of delayed consequence. The Milky Way is not merely one example of these truths. It is one of the grandest familiar demonstrations of them. That is why looking up changes, but not in the sentimental way people often promise. The sky does not become a comforting friend. It does not become a spiritual mirror. It does not become ours in any triumphant sense. It becomes more exacting, more difficult to consume as scenery, more resistant to being turned into an emotional backdrop for human moods. The old innocence is gone, and what replaces it is not mood but orientation. You know, now, that the bright band above you is only the visible fraction of a deeper structure. You know that its outskirts carry remains of other worlds. You know that some of its future is suspended in gas too diffuse to see. You know that its stars are not first things, but consequences. You know that the shape you inherited is temporary. You know that even now, the larger future is approaching, slowly enough to feel like abstraction, only because human time is so narrow. Knowledge does not make the sky louder. It makes it harder to misread. And perhaps that is the most honest form of reverent science can offer. Not adoration, not theatrical amazement, not forced humility. Precision held long enough that the thing in front of us is no longer simplified into a version that flatters our habits of thought. The Milky Way deserves that precision because its real form is stronger than any simplification we would impose on it. Call it a star city and you lose the halo. Call it a machine and you lose the fertility. Call it home and you risk forgetting the violence. Call it a predator and you risk forgetting the light. Call it beautiful and you risk implying innocence. Call it terrifying and you risk ignoring the calm by which most of its deepest processes actually proceed. None of the easy emotional summaries survive. What survives is harder and better, a structure lawful enough to be understood in part, vast enough never to become emotionally easy, intimate enough to include our own bodies in its history, and unfinished enough that its present can only be read as one phase. That unfinished quality matters more than almost anything else, because it restores tension to the universe without inventing it. We do not need to fabricate mystery where science has already clarified mechanism. The tension is already there. It lies in the gap between what a thing looks like and what it is doing. The Milky Way looks settled. It is not settled. It looks bounded. It is not cleanly bounded. It looks luminous. It is ruled largely by the unseen. It looks like a place. It is a process that temporarily takes the form of a place. Once a mind has really absorbed that, it cannot return entirely to the earlier world. Not because it has become disenchanted, because it has become more difficult to fool. That is the kind of transformation worth aiming for in science storytelling, not the delivery of facts, not even the generation of awe by scale alone, a change in perceptual integrity. The viewer begins with something seemingly understandable and ends with a subtler, more demanding picture of reality, one in which the most familiar large structure in their cosmic life has lost its false simplicity without losing its beauty. The Milky Way remains magnificent, but the magnificence no longer rests on size or spectacle. It rests on structure, on the exact, layered, lawful way, hidden mass, inflowing gas, stellar birth, stellar death, tidal stripping, orbital memory, and future merger all belong to the same continuing story. A story in which nothing stands wholly apart, in which matter changes role without leaving the drama, and in which visible form is always only one chapter in a longer grammar of transformation. The galaxy does not need our metaphors to become profound. It is already profound by being real. And so, the descent reaches its final edge. Not toward a conclusion in the ordinary sense. Conclusions imply closure, and closure would betray the subject. A galaxy like the Milky Way does not end cleanly in thought any more than it does in space. It fades outward in gradients of influence, backward into inherited structure, forward into unfinished motion. The most honest ending, then, is not a summary. It is a return with altered eyes. Return to the first image. A clear night, the dark overhead, the pale river spanning the sky. Nothing in the image itself tells you what it really is. That is part of its power. To the eye alone, it remains almost offensively simple, a band of diffuse light, ancient and beautiful, serene enough to carry myth, memory, and human longing without resistance. It offers no visible hint that the galaxy is held together largely by unseen mass. No hint that its halo contains the remains of consumed systems. No hint that gas above the disk is carrying future stars in delayed form. No hint that a black hole waits at the center under contingent hunger. No hint that another giant spiral is already moving toward it. No hint that the elements in your blood were forged in older stellar deaths that belong to this same long history. The image stays quiet. The knowledge does not. And that is the final gift of the Milky Way, once it is understood. It leaves the surface intact, while permanently changing its depth. The sky does not need to become visually different for reality to become more visible. A familiar thing can remain familiar in appearance and still lose every simplifying story once attached to it. The universe rarely tears the mask off. More often, it leaves the mask in place and teaches you how to see through it. What crosses the sky above us, then, is not a monument to completion, not a celestial painting, not a finished homeland, not a still arrangement of stars resting in eternal form. It is matter in continuity, memory in orbit, fuel in transit, light after delay, structure after violence, future already inbound. It is not the memory of a galaxy. It is a galaxy still happening, and that is why the final change is not in the sky. It is in the act of seeing, because once all of this is understood, the Milky Way can no longer be honestly experienced as a fixed celestial object. Not if the understanding has really settled in. Not if the hidden engine has replaced the old image deeply enough. The band of light remains where it was. The dust lanes still cut through it. The stars still burn with the same indifferent patience. But the interpretation has broken. What was once a thing has become a process. What was once a place has become a transfer of matter through time. What was once a backdrop has become a live structure of capture, delay, recycling, memory, and future consequence. The old sky was easier to love. The new sky is harder to look away from. That hardness is not cruelty, it is precision. The universe has not become more dramatic than it was before. It has only become less willing to cooperate with the emotional shortcuts we bring to it. We wanted the Milky Way to be a resting image because resting images are easier for the mind to hold. But the real galaxy is not offering rest. It is offering reality. And reality here is a severe kind of continuity. Small galaxies fall in and lose themselves. Gas enters the halo and waits in forms that do not yet shine. Clouds collapse only after long, invisible preparation. Stars ignite, age, and return heavier matter to the larger circulation. The central black hole remains quiet until supply changes. A larger merger approaches through a future that is already physically underway. The visible disk glows through one temporary phase of a structure that will not keep this shape forever. Nothing in that chain is theatrical. Everything in that chain is immense. That is the final maturity of the subject. The Milky Way does not need to be narrated as a monster, and it does not need to be protected from its own implications by soft language. It is enough to say what it is: a galaxy that grows by incorporation, a galaxy that carries the remains of earlier worlds in its halo, a galaxy that keeps future stars suspended in invisible reservoirs, a galaxy that made our chemistry out of older fire, a galaxy whose current elegance is only one interval inside a much longer physical history. The river of light is not innocent. It never was. That does not diminish it. It restores its true scale. Beauty becomes heavier when it is no longer mistaken for simplicity. The Milky Way is beautiful not because it escaped violence, but because violence, lawfully prolonged, can produce structures of astonishing coherence before they pass into other forms. It is beautiful because hidden mass can hold a luminous order together for billions of years, because gas can cross impossible distances and eventually become stars, because a galaxy can feed on smaller systems and still give rise to worlds, because temporary form can be this graceful even when it is not final. A spiral galaxy is one of the universe's most elegant temporary achievements. Temporary? That is the word the mind resists. It always wants one more refuge from it, one more scale at which the world becomes fixed at last. But every time the Milky Way is followed honestly, the same lesson returns in a larger voice. There is no scale at which reality owes us permanence in the emotional sense. There are durations. There are stable regimes. There are long-lived patterns. But there is no final exemption from becoming. Even galaxies are transitional. And still, not merely despite that, but partly because of it, they can mean something real. Not meaning as cosmic intention, not meaning as a message written for us, meaning in the stricter and more durable sense that a thing can matter because it reveals the structure of the world truthfully. The Milky Way matters because it discloses how reality actually works when human intuition is no longer allowed to flatten it. Hidden causes beneath visible form, process beneath stillness, reorganization beneath growth, permeability beneath home, delayed consequence beneath light. The galaxy is not teaching a moral, it is exposing a pattern. And the pattern does not end at the edge of astronomy. Once seen, it follows you back into everything else. You begin to suspect that many of the most stable things in experience are stable the way the Milky Way is stable, not by being finished, but by being maintained through movement, exchange, and concealed depth. You begin to distrust surfaces a little more intelligently. You begin to feel that the visible world is honest, but not complete. You begin to understand that permanence was often only persistence viewed from too close a timescale. The Milky Way is the correction large enough to make that lesson unforgettable. And then, at last, the title resolves fully. The Milky Way devours galaxies every single day. Not because somewhere out there a giant object is performing cosmic cruelty for dramatic effect. Not because the universe is secretly trying to shock us, but because a galaxy like the Milky Way is, by its nature, a deep gravitational regime that continuously absorbs, strips, stores, circulates, and transforms matter. Smaller galaxies enter and lose coherence. Their stars become halo memory. Their gas becomes part of a wider fuel economy. Their separate histories are folded into a larger one. The act of devouring is real, but it is only one visible aspect of a deeper law. What the Milky Way truly does is convert other endings into its own continuation. That is the most exact sentence in the whole descent. And it brings everything back to the body one final time. Because if the galaxy continues by converting endings into new structure, then our own existence is not merely located inside that process, it is composed by it. The iron in blood, the calcium in bone, the carbon that once passed through stars and clouds and older wreckage before becoming briefly arranged into a thinking body. All of it belongs to the same continuity. We are not looking at a machine from outside. We are a late local arrangement of matter that the machine made possible. The galaxy became capable of asking what a galaxy is. There is no need to decorate that thought. It already carries enough weight, not because it proves the universe is benevolent, and not because it places us at the center, but because it reveals an intimacy more difficult than either. The laws are indifferent, yet they are not foreign. We are made of what they do. We belong to reality most deeply where reality is least adjusted to our preferences. That is the final residue. Not comfort, not fear, not simple awe. Something cleaner. A haunting clarity that the thing we call home was never a resting place in the cosmos. It was always a luminous interval inside an unfinished gravitational history, one that fed on smaller worlds, stored its future in hidden gas, forged our chemistry through older death, and is already moving toward a later form in which even this familiar river of light will no longer remain what it is now. So, look up one last time. Not to recover innocence, that is gone. Not to force wonder, it no longer needs forcing. Just to see the image after the disguise has been removed. The band across the night is still there, soft, ancient, beautiful enough to seem almost merciful. But now you know what crosses that darkness. Not a static galaxy, not a finished home, not a monument to permanence. A system still feeding, a halo full of remembered ruin, an invisible ocean of future stars, a center waiting under conditional hunger, a larger merger already on its way, a long chain of matter turning loss into structure, structure into light, light into chemistry, chemistry into bodies, and bodies into thought. The Milky Way does not simply exist above us. It is still becoming, and what we see at night is not the photograph of that becoming, it is the wound lit from within.